Blind man don't blink, quiet man be quiet, wise man don't speak, pious man be heard. Go and branch your sheep, go and dig your holes and plant your seeds. Go and bridge your gaps, and if a tree sways, go and get your axe. Don't forget your roots, don't commit too fast to sell soul for soup and trade gold for glass. Some cast nets and some cast iron, some catch fish and some catch fire. They say that friendships never die, what a lie. Broke man don't break, money buys you power, won't give you strength, it won't bear your child or give you faith. When you get your cut, it won't fix your pain. You got deep roots. Try to hide it with a smile, but we know you got a sweet tooth. Yeah, me too. Rain clouds come and go, some bring life and some bring snow. They say that friendships never die, what a joke. Clever man, you tried to put me in a box, nice try, get a better plan. I keep a level head, I don't settle, never did measure me, you need steady hands. I done hit rock bottom, got a pen and drew a set of plans. What I built wasn't sand, so understand that I don't feel guilt. I know a tree without water gon' wilt. I know snakes in the grass keep rats out the garden. I know kids cry over spilled milk.
What is up, ladies and gentlemen? We are excited today to bring you the first ever TED open panel. Very, very exciting. Cannot wait to get things kicked off with you all. Thank you for being here. It's been a little bit of a wait since our last True Earth thing, and that is because the last one I did on TikTok got me struck, and so I didn't have anything to upload for you guys, and then life happens. But we're here now. And so we do appreciate everybody for being here. Nuba, huge shout out, man. Before the show even begins, we have a $5 tip. Absolutely incredible. You guys make it possible to really put in my best effort when I know that you guys want to sponsor me. So if anybody else would like to be so kind, feel free to head on over to the Rokfin. You can sign up for a subscription. That way you don't have to worry about where your monthly piece comes from, at least on my end. Or you can go to Buy Me a Coffee over here down below. Really, really fun. That is actually my favorite way to donate because it stops the whole show, and we can go ahead and read your comment live. So really, really fun. Go ahead and do that if you wish. We did miss the FMX edit. You know what? Let me go ahead and play this real quick. So, just a little bit of a hint to who may be coming on the show today for those who may recognize that song. It's going to be really fun. Going to be fun. So, who knows who we're going to get on? I dropped links in TikTok, dropped links in Discord. It is open panel. Not sure how many guests we can fit in it, but we're doing it Google Hangout style, so it's going to be pretty interesting to see what we have for today. I think it's just black screen. Sorry about that. All right. So before we drop the link, let the guests on, I did just want to go over a couple things. The first thing is that if you did not make it to one of the FE meetups this weekend over on Saturday, That is very, very unfortunate. Awesome time, super mellow vibes. Go figure. The one that I went to was hosted by the Mellow Dome over in Lady Lake. So very fun. We're going to be planning another one here and give people a lot more forenotice, so you can go ahead and plan your vacation down to Florida. The event will most likely be free. Who knows? There's tons of free stuff to do here in Florida, and there's tons of paid stuff too. So it just depends on what everybody's trying to get into. But just a little something to look forward to for the future. You can check out some of the live stream that we did during that meetup over on the Mellow Dome. So definitely go check him out if you haven't given him a sub. I'm not sure what you're doing. Um, I like to think that a lot of my audience watches the same people I do, but that might just be me. So, alrighty. So, the true Earth debate, in the spirit of it, I wanted to go ahead and introduce just a few things. Before I do, though, let's go ahead and give a shout out to the chat here. I'm going to go ahead and start over on the Rokfin. Obviously, we already got you, Nuba. Thank you so much for the $5 tip, MVP, before the show even began. And we also got Mischief Brew. Yes, Troubling Tribune is in Florida. That is where my base of operations is. So if you want to link up, get at me on Telegram. It's the easiest way. Right on. So that will conclude the Rokfin. Let's go ahead and head over to the YouTube. Let's see what we got crack-a-lacking over there. Ruhif. We join the stream here in just a bit. I'm going to be dropping a link. Anybody can hop on in. Doug Maurer, welcome. Thanks for coming on, man. Pacao McCliver. Double T, non-rotating, stationary level, horizontal, topographical, geocentric plane. Very well said. Don't think I could have said it better myself. And, of course, Effed Up World. We appreciate you. Thank you for stopping by. For this discussion, we are not going to be cutting over to the Rokfin at all. So this is going to remain free on both platforms. That way we can get the most diverse panel possible for these. And hey, if it goes well, we may make it a reoccurring thing. So be sure to share the show with your nearest and dearest Globy friend. And that way we can go ahead and have a fantastic discussion. I actually loathe echo chambers. So it might be a surprise to hear, but I actually would like to try to get some opposition, some people with some different opinions in. And but that doesn't mean, if you feel like we agree on everything, that doesn't mean don't hop in, right? Go ahead and hop on in, kick it for a moment. And yeah, hang on out. So let me go ahead and give you guys this little quote in the spirit of things to get things kicked off. We have this quote from Nikola Tesla. A lot of you folks are probably familiar with this quote. Today's scientists have substituted mathematics for experiments. They wander off through equation after equation and eventually build a structure which has no relation to reality. Very interesting. I wonder what things today could resemble that statement. Just a few things. Alrighty. I'll go ahead and drop my main FE proof also, just to kind of handicap myself a little bit. I know a lot of people in like Debate Tactics 101 is like, oh, you shouldn't do that, but I actually don't care. We'll go ahead and put it right out on the table. So again, before I drop the link and let everybody try to tear it up, we have another J. Tolan Media special. Texas to the coast of Baja. You have some landmarkers here. Go ahead and squint, scrutinize, screenshot. He does do a pretty dang good job of lining up the landmarks on Google Earth. And this right here, even if it's taken from hell, let's say 50,000 feet high, which we know it's not that high, you would still have hundreds of thousands of feet of missing curvature. Absolutely ridiculous that people still believe that we live on the spinning space ball, hurtling through space at multiple different vectors. didn't really make sense to me once we started scrutinizing it. But hey, there's a lot of indoctrination that we have to dig through. You have to remember that we were pretty much force fed the globe from the time that we were very young. Heck, I'm seeing some children's books that just have just have it right there. Pure indoctrination. But hey, a great way to avoid indoctrination is to bypass the YouTube algorithms with the Flat Earth, Sun, Moon, and Zodiac Clock app. If you have not jumped on that, you are missing out. All the blue dots, the community. We actually had some people show up to the Mellow Dome meet and greet, the FE meetup over in Lady Lake, using this app. They never even heard of the Mellow Dome. Can you believe that? So they saw the meetup posted on this app by Dr. Law, I believe it was. And yeah, they ended up finding the meetup, finding us, and now our community just got a little bit bigger, a little bit brighter. So get yours today and make sure you use your referral code Tribune. That way they know that I sent you over there. And you get that little blue dot, pop. They know that a flat earther has been born. An angel has gotten its wings. Alrighty. Now, folks, because the TikTok has gotten so dicey, it has become way too unreliable to promise you guys a TikTok version of the flat Earth debates. It's like they try to censor every other one that I do. So I highly recommend that you go get over on TikTok. It is free. Just costs you a little bit of your data to the Chinese. No worries there, though. I'm sure there's nothing on there that's too bad. But yeah, go ahead and do that. That way you can stick with it whenever we go live here. I use this picture facetiously. But a lot of fun over on the TikTok. We get a lot of different people over that you usually don't see over here on YouTube. So definitely check it out if you haven't already. It is a lot of fun. And of course, my last little plug here. Let's go ahead and make sure that if you want to support, surprise, right? Surprise and support all of your community, your content creators over on Rokfin, content creators like the Mellow Dome, like Jaronism, like Owen Benjamin, Karen B. There's really no reason, if you like this kind of content, that you shouldn't want to support all those content creators in one place. So go ahead and subscribe to Rokfin. It's only $15 a month. What a steal. And you get all the truther content algorithm free. It's not going to hide itself, the juicy nuggets, like it does on YouTube. And it will actually suggest for you things that you might enjoy. So I actually do most of my research that I can anyway over on the Rokfin. So go ahead and subscribe. And hey, if you're not in the position, that's okay. Go ahead and get a free subscription. You can still get all the free content over there at Rokfin. So really awesome that you can show your support. You also get the nifty little feature of being in our comments over here and being able to donate through the Rokfin, which is really cool. But if you do not have that, feel free to go to buymeacoffee.com. That way you can have your super chat still read. Alrighty, that is enough plugging for one day. My goodness, exhausted just from that. Let's go ahead and open it up. Give me just one moment to famous words, right? Let's go ahead and slam a drink of water. I'm going to be dropping a link here for a Google Meet here in just a moment. So because I didn't want to waste the time in it, I went ahead and saved it because I didn't want to get booted. So you do got to give me just one little eensy-weensy second here. Fun stuff over here at the Troubling Tribune. I wonder who will join the panel today. I have a good feeling that we'll get at least one Glober on. At least one. But we shall see. If we end up with the echo chamber, hey, that's fine too. We'll just turn it into the FE hangout. Whatever ends up happening, we are cool with. All right. Finally, copied. Nice. All right. Try not to leave you on that too long. Alrighty. Here we are, the Google Hangout. Let's go ahead and get this thing off of the screen. And let's get this posted into the chat. So first go is obviously going to go to the Rokfin. First come, first serve. They got privilege. Sorry, guys. It is what it is. But let us also go over to our YouTube here. Make sure you guys get the link as well. Awesome. It's still showing up. No issues. Perfect. Looks like this is going to work a little bit better than last time. Okay. Oh, man. Lots more people showed up to the chat over here on YouTube. Shout out to Annette, Sovereign Soul, Creature. Appreciate you guys coming on. Let me go ahead and post this for you guys. I'm not sure exactly how many people I can accept in the in this chat, but we are going to find out today. So should get some guests here in just a moment. Alrighty. I know it can be pretty intimidating to step in with the Tribune if you are on the opposition. Just know that it is okay. We're not going to bite your head off. We're going to go super easy, super cool. Just make sure that we get the facts out, dig through the fallacies, right? And that way we can obviously walk away as better individuals. So definitely do not hold back. Hop on in. Flat earthers, globe earthers, concave earthers, whatever your opinion is, feel free to go ahead and join us. We got quite a few recognizable faces, so definitely looking forward to see where this conversation goes. Today, I really hope that we can tackle into some celestial navigation, some of those demonstrable flat Earth proofs, and see if we can get any kind of consensus on what reality is. Because I know that a lot of people walk into these things thinking, "Oh, there's no way that I'm going to convince anybody." And I'm sorry if you feel that way. You probably shouldn't come on. I firmly believe that if you believe you have the position of logic and reason, then you should have no problem championing that as truth. So should be pretty fun. Let's see, am I just missing something here? Let's show everyone. Nice. It's gonna freeze my face there. Perfect. Awesome. Well, not everybody at once, right? Don't everybody jump in at once. Yeah, they're crying. Hey, there he is. We got our first guest, possibly our best guest. Welcome to the show, Adam Everest.
What's going on, man?
What is up, my friend? Just starting off this panel, really excited to get the conversation going.
Yeah. Will you be able to share your screen off of this and stuff so I can see everything?
I am pretty sure. I hope so. We're going to find out.
Okay. All right. What's going on, man?
Man,
a couple weeks, huh?
Yeah, it has been an exhausting couple weeks. I've had a lot of BS going on, but one of the highlights, of course, was the FE meetup that we had. I was actually surprised that you didn't make it over there.
I seen something that also had posted today. So, what day was it on?
It was Saturday.
Okay, yeah, no, we've been out of town and just
Oh, that's right. That's right. Yeah, absolutely.
Yeah, man.
I totally forgot about that.
But yeah, yeah, man. celestial navigation, man, was a good topic.
Yeah,
I,
absolutely.
um, I dug in with the kids on, and we did that experiment with the fish tank, and we're actually doing that for my daughter's science fair project coming up in February. Man, it's gonna be dope. I hope I hope we get first place.
That's awesome.
Yeah. So and then we got some I got some other stuff going on with the kids and just inviting the kids over and doing experiments and just yeah, it's been cool, man. It's been fun.
Heck
But
yeah.
where you want to start, man? You want to you want to you want to start with celestial navigation? You want to touch back on some refraction?
Well, I pretty much I feel like I opened up the gate pretty strong with the Baja from Texas observation, and so we can touch on that. Yeah, we can just continue on from there wherever it takes us.
All right, so I didn't see that.
Ah, gotcha. Jumped in a little bit late. Give me 1 second. Let me see if I can pull it up. Are you still on the stream muted by chance, or
No, I'm just here on the Google Meet.
no worries? Let me see if I can. Let me see if I can do this. All right, now I figure now's as good a time as any to test the screen share. Notice my picture has disappeared as soon as I click off of it. That's not good, but oh, there we go. We're back. Oh, cutting out. No worries. I'm sure it will straighten itself out here momentarily. All right, let me get this up for you. You know how it is. My computer, of course, wants to be super slow pulling up anything, but luckily not too slow on the conversation. So
Yeah.
I'm noticing there's very low latency this time, so I think we're in for a good one.
How long was it before I called in after you posted the link?
Not very long at all. Not very long at all. What the heck was that sound? Was somebody else trying to come in? Missed you. Missed you if you tried to come in. I got this thing pulling up. It's just taking its sweet, sweet time. I'll give you a little bit of information on it while it pulls up. Basically, this photograph was taken with an infrared camera lens, taken from an airplane in Texas. Where the heck are we? Okay. All right. We're going to test this. This is going to be interesting. All righty. Let's see here. It says it's sharing. Let's see if it pops up.
Yeah, yeah, I can see it.
Okay, perfect. Perfect. The audience can't see it too great, but if you can see it, that should be good enough because I showed it to them just a little bit ago. So this was taken with an infrared camera from an airplane by J. Tolan Media. It is the Texas to Baja observation. He goes into Google Maps. He lines it up. I did the math on it before on if it was 50,000 feet high, and it came back that there should have been like at least a couple 100,000 feet of curvature. I'll have to double check it to get the exact number, but it was astronomical. It was a lot. And it makes sense because we're
What's
talking
the
about,
distance?
let me pull it right here. It is 760 miles.
What was the height of the aircraft?
50,000 is what I had it at, but it was probably lower than that. Average aircraft flies about 30,000 feet.
30,000 feet. I mean, I don't see a problem with that, man. And then you guys you really don't believe in refraction, huh? I know the last time we talked, you were telling me that the light bends down and it never bends up. Did you ever watch that video that I
Yeah, I don't.
sent you that Austin sent me?
Yeah, I don't. I don't know if that's exactly what I said, but if I did, then I'll issue the correction. The light bends into whatever the denser median is, so whichever, and it depends on
Okay.
the angle that it hits. So you can have instances where the light does bend up.
Yeah. Okay. All right. So I don't know how much refraction is going. I don't know where the sun is. Um I have no idea where any of the stuff is in the picture, and I think that does play a lot of toll because refraction will happen when the sun is at different angles shooting through the atmosphere. Um, and when the light bends down, it's from a position from your eye. So if you're looking at something, it's almost like the light is meeting your eye, right? As far and then I don't know, like the way I was describing it to my kids, like the lasers are like your eyes and you have X-ray vision. So when the laser goes through the water, so the sugar acts like the cold air. The cold air is a denser medium. So when you add that to the water and then you shine it through, it bends and it goes down. So this is actually what you're seeing. And I thought it was kind of cool because you can actually see. I rewatched the video that you had posted with the sailboat and how it seems to dip below the horizon, and that happened to us too. However, when you shine a laser from the back of the picture at the bottom of the buildings or the bottom of the picture, just whatever you're looking at, and you sink a camera down below, you'll notice that the camera or the that the vision or the visual, whatever you're looking at, it actually compresses. The picture compresses. So you're looking at atmospheric compression. So and you can see the laser, all it's all visible, but it just gets smaller. It compresses it. So again, I don't know. It They said a picture's worth 1,000 words, but I don't know everything about this picture. He's got infrared. We don't know where the sun is. We don't know. We're assuming how high he is. He's over the clouds, so you can assume he's pretty high. Um, and again, I disagree with you on the curvature, the way it's depicted, because the depictions that you guys follow are all based off of the tangent line, and it's it's just not for me. It's not a representation of what the reality is of what we're actually seeing.
So when you say that we're just basing it off of a tangent line, I'm literally, again, I use the Walter Bislin Earth Curvature Calculator. There's like very little disagreement on that in the globe Earth community. And so I was just redoing the math just to show you kind of what I was coming up with. And observer height, let's say 35,000 feet, target distance 760, target size 10,000 feet. I don't know exactly how high that mountain is, but it's irrelevant. So, and it is at zero refraction right now, but we can play with that here in just a moment. So, put it all in miles and feet. The Sagitta, the bulge, is 96,223 feet. The amount hidden because of the geometry of it is 189,501 feet. Okay, so if we are looking at a mountain, even if it was double that, 20,000-foot mountain, you would still have the same amount of hidden of that mountain, 189,000 feet. You definitely would not be able to see it. So if we introduce refraction, let's just do standard refraction. I said, let's just do standard refraction. 1 second. Alrighty. So with standard refraction, you still have a bulge of 76,735 feet. and a hidden value of 135,400 feet. So even if we assumed, let's assume super refraction. And this is, no geographer, no geodetic surveyor would ever calculate refraction to be this high. I have it at 0.5, which is astronomically high. It still gives you a hidden value of 63,321 feet and a Sagitta of 48,060 feet. So no matter how you slice this, and he confirms the landmarks in his video, no matter how you slice this, that mountain should be completely invisible if you're viewing it from Texas.
I mean, and again, I don't know anything about this picture. I know that you can sit here and you can tell me about this picture, where it was taken from, how it was taken, but I don't know anything about this picture.
Hey, Ruhif, welcome to the show. Thanks for coming on, man.
Yo, yo.
What's up, man?
Oh, let me mute the stream. There we go. Boom. What's the haps?
Not much. We were just getting into the J. Tolan Media Texas to Baja observation. I just broke down the math for our resident glober, Adam Everest. And, of course, his best rebuttal is that he doesn't know enough about the picture. So,
okay, I do. Let me find a video I did on it. One sec. My videos. It's an unlisted video. Go. Where can I copy a link to you? In the Meets chat somewhere?
Yeah, go ahead and drop it in. What are you on, YouTube or Rokfin?
YouTube.
Yeah, drop it
chat
in
with
YouTube.
Everyone. There we go. 2-minute debunk of this observation. Done.
Excellent.
1 minute 33, actually.
That is what we come to see.
Yeah. So do you want to just play that on the stream?
Yeah, give me 1 second.
Yeah.
I'm waiting to see it. It's like stuck on Jeff Hyatt. Shout out, by the way, to the chat. FE Nation, Jeff Hyatt, Paku McCleaver, Nuba. We appreciate everybody tuning in. Yeah, it's still stuck on what is holding us up. Let me see here. You can actually have the ability to present, correct?
Oh, do I? Present my tab. Let's present a tab.
Okay, let me go ahead and pin you.
One. Right, share the audio from the video as well?
Yeah, absolutely.
Cool. All right. So let me know when I can press play.
Actually, let me pin the video.
Ready?
Let me unpin you and pin the video.
Yeah. All right.
That way we can get this more user-friendly for the audience.
Yeah.
Okay. I'm still learning how to work this
Just
thing.
say that.
So. All right, it should be.
I've got no idea. I've never done a live stream. All right, am I ready to go?
Yeah, you should be good. Go ahead.
Okay, all right, press play. Boom. Alrighty, so the claim is that this mountain here is Cabo San Lucas at a distance of 760 miles. And he also claims that we can see the Gulf of California. So before we can analyze it, we need to know where he was when he took the shot. Thankfully, he gives us a few seconds of GPS coordinates between the 25-second mark and the 29-second mark. And then in some unbroken footage, he actually takes the shot that we're looking at the 68-second mark. So we could just do an extrapolation in Google Earth, which is fine. but if you can be accurate, why not be accurate? So here's some Python code that does the extrapolation for me, and these are the coordinates that I'll use as his observer location. Now, for literally no reason whatsoever, I'm going to drop a big red blanket onto these Chinati Mountains in Texas, and for that I used the polygon tool in Google Earth. And then we had a bit of a play with the heading and the tilt and the field of view just to get all the landmarks lined up. All right, now let's start fading out, shall we? So here are the mountains we're looking at in Jay Tolan's image, and let's do it. Uh-oh, that's no good. And I think we're done here. The end. There we go. Yeah, so he's not looking at Cabo San Lucas. He's looking at Chinati Mountains about 210 miles away, I think it was. As is often with Jay Tolan, he misidentifies a lot of stuff. So.
I mean, I'm willing to accept that as a possibility. It's just maybe I just needed to make it bigger. I don't know, but to me, it kind of looked like it kind of looked like a different mountain range. But I was on a small screen, so but you
post the link in the YouTube chat, and people can like freeze frame it and slow it down or whatever else. Yeah, but
yeah, for sure.
It's Absolutely. Not Cabo San Lucas.
Yeah, it kind of looked like in the image that there was some, water in there, like there was a coast. So, but again, I'd have to take a closer look at your video there.
Yeah, no, that's all good. Yeah, stick in the chat. Absolutely. It's unlisted, so it's yeah. Anyway, all right. Next, what's the next one?
Nice. Dude.
I actually don't know who you are. Like I've never seen your name in Discord before, so I got no idea who you are.
Awesome, man. Well, welcome to the show. I definitely appreciate you coming on.
Thank you.
I posted it in the Discord, as a Hail Mary to see who we could get to come on, and because we were trying to get more Globers on, but I definitely appreciate it. So, absolutely. Yeah, I definitely have plenty of these to go through. I'm sure, and I will preface this.
So can we calculate 210 miles on the Walter Bisley calculator?
Sure.
Adam Everest, I have seen that name before.
Check me out on Spotify, man.
Yeah.
210. Do you happen to know the target size?
Chinati Mountains. Hold on. I'll see what the biggest mountain is there. The highest point in the range is 7,728 feet, or 2,355 meters. His elevation, let me just go back to the video. His elevation would be, is that 35,400 feet elevation of the plane, obviously.
I just do the base numbers because I'm not one of those people that has to be super nitpicky. I think we can agree if the math works out, the math works out. If it doesn't, it doesn't, unless it gets to an extremely small margin. So let's go ahead and do it. We got observer height 35,400, target distance 210, target size I put 8,000. And we have a Sagitta of 7,351.88 feet. However, because we're so high up, we can see up over that bulge and see that mountain with nothing hidden. So if it is that mountain range, the math would check out, but I would have an extremely hard time believing, based on that photo, that I'm seeing a 7,000-foot bulge in between the observer and the mountain. Usually I can, even if I'm looking over top a hill, I can usually tell something like that, but hey, to each their own, right?
I don't think there's even a horizon at 210 miles, 35,000 feet, is there? Pretty close.
Let's see.
35,400, 210. Oh, by 38, yeah, a little bit. So refracted horizon, 250 miles. Distance to the mountains, 210 miles. So that's pretty close. But we can always that rendering I did in Google Earth is imprecise because Google Earth doesn't do refraction. I can probably render it more accurately in a proper 3D renderer and get a better shot to compare it to. I mean, the mountain shape checks out. So
It kind of looked like it shifted angle a bit, but I suppose if you invoke extreme bendy light, you could probably correct for that.
yeah, not extreme bendy light, just regular bendy light, just
the standard amount of
Yeah.
bendy light. It's absolutely
Yes.
hilarious. Have you heard of the
Light does bend, man.
right? But it doesn't bend in every single scenario. So
Yeah, it does. Yes, there is always a
Yeah.
density gradient in the atmosphere. Always, you cannot ignore refraction.
So
Awesome.
my biggest thing when I did start looking into refraction was I noticed that the flat Earth community, they always base it around frozen lakes, and this is when the
Correct.
density is the highest. And it's crazy to me. And then they use violet lasers, which have or blue lasers, which have the highest amount of refraction when going through a dense gradient.
The color doesn't matter so much, but the fact that it is on an ice lake means you don't have as much of a temperature gradient, which means stronger refraction. So if you're on a really cold surface, you could even have the air above it warmer, which would give you extreme refraction. Like you've got a temperature inversion, so that would give you an extreme refraction, and that's what happens over ice. So you've got that the Grouter 1 guy doing that 7-mile observation of lights. Yeah, that's perfect perfect conditions for extreme refraction. So
yeah, when I was talking with a geodetic surveyor who had to account for refraction, he said the ideal conditions to do an observation would be between about 60 and 70 degrees Fahrenheit, and that the main thing that we do look for is going to be temperature inversion. Now, the issue that I run into, and maybe I'm just misunderstanding this, but I do know that when you have a cold front come in and the water usually takes a lot longer to change temperature, that is going to give you a prime example of a temperature inversion, which can cause refraction. However, when you have frozen water, frozen air above the water, I'm very familiar with the duct effect. The problem is that it, when diagrammed out, doesn't seem to make very much sense with the way that light travels, because it's supposed to go down into the denser medium. If it's already in the denser medium, it's already in the cold air. When it hits the hotter air, it's not going to bend back down. It's going to, because of the direction, it's basically going to be released out into that. It's not running into a denser median. It's running into a less dense median. That's not going to change the direction. Unless
the direction light bends is always towards the denser medium, right?
But it has to hit.
That is even the case.
It actually has to hit a denser median to do that.
No, if you let's say the more dense air is at the bottom and the less dense air is at the top, right? So we've got the typical structure of this atmosphere: more dense, less dense. If you angle a light ray up, right, as it travels, it does hit less dense air, but the direction that it bends as you go up will bend that way, right? It will bend towards the denser medium.
Can you demonstrate this? Because I do know that light does bend when it goes into a denser medium. Nobody is denying that. The problem is that it's going from a more dense medium to a less dense medium, and you're trying to pretend that it boomerangs into the more dense medium, even though that's completely contradictory to the direction the light is traveling.
The direction that it bends. So if, let's say, it goes that way through from more dense to less dense, right? It hits the imaginary boundary between the two. It can either bend that way or it can bend that way. All right. It will bend that way. It will bend towards the more dense medium. So it's still hitting air that is less dense as you go up, but the direction that it bends from the direction it was traveling is towards the more dense medium. So it's not a fact of going into a more dense into a more dense medium. It's which direction does it bend.
That's actually one of the key things when looking up refraction. That says it's a prerequisite. It does have to go into a denser medium.
No, that's not
so
Snell's law.
In any case, could you perhaps demonstrate this? Because we definitely agree that when light goes perpendicular, or sorry, yeah, that's the direction. When it goes straight across through the denser gradient, it's definitely going to bend the light down. We've seen examples in frozen areas where it bends the light up. Can you show us where this light is bending back down into a denser medium, going into a less dense one?
Refraction. Whoops. Yeah. I've got a slide somewhere. Where is it? Oops. Have a Snell's law? Fuck, I need a Snell's law slide.
I would say that even if you did have a slide explaining how it would work, I would still want to see it demonstrated. Because it can,
well,
you can have a theory about how it works, but I'm sorry, go ahead.
Do you accept Snell's law?
Yeah. Refraction does happen.
Let's, okay. Let me share this one. Hold on. Share a window, and it will be that one. All right, so I'm sharing Snell's law. So we've got the top. The top is obviously air or something, and the bottom is water or glass or whatever it happens to be. But N1 is more dense than N2. So we've got our ray of light going up. So from the bottom, from the more dense medium into the less dense medium, right? And it bends towards the more dense medium. That's just the direction it bends. The direction in which it bends, it could either go left or right, right? But it's bending towards the more dense medium. That is Snell's law. So it could bend to the right and bend away from the more dense medium, but Snell's law is it bends towards the more dense medium.
Yeah, so I've seen that those little arrows, of course, can easily be flipped around to be going the other way. And again, it does depend. Yes. It does depend on the direction, right? So
no, it doesn't depend on the direction. Well, does not. It's reversible, completely reversible.
So what I mean by that is that the amount that the light bends depends on the amount of change between the medians and the direction that the light is traveling initially.
Not the direction. Direction does not matter. The path is the same. Direction does not matter.
If you have a different initial direction, how would it not change the path?
No. If you're going from the more dense to the less dense, right, it will travel along a certain path. If you then reverse that, going from the less dense to the more dense, it will be the same path. Snell's law applies the same in both directions. That path will be the same. I see what you're saying.
Doesn't matter if the light's shining in or out.
Yeah.
It's light.
Yeah, direction doesn't matter, but whatever direction it's going, it bends towards the more dense medium, whatever direction it goes.
Right. So can you show me, because obviously this isn't boomeranging back into the more dense medium. It's still going off in what I would consider off into almost perpendicular.
Yeah, but the beam of light is just the beam of light.
Yeah, this is just happens to be angling upwards, right? How about you have something going horizontally and it will bend down?
That's exactly... So when I'm seeing the diagrams for the duck effect, it's literally they're just drawing the line in whatever they need it to fit. There's no real mathematics behind it. Can you actually show something demonstrating that?
There's absolutely mathematics behind it. What do you want a demonstration of?
The duck effect, where you have the column...
The ducting?
Yeah, where you have the column of hot air sitting above the column of cold air.
Yes. So basically we measure... You can measure the refractive index in the air by taking vertical measurements. Let's stop sharing that one sec. There we go. You can take measurements of the temperature, pressure, humidity as you rise vertically. All right, and with those individual samples at different heights, you can work out a refractive index. right? So, at whatever, 20 meters above the ground, the refractive index is this. And then you take another sample 100 meters up, whatever, the refractive index is that. So we know that the average refractive index between that point, we know the gradient, sorry, we know that the average gradient through that 80 meters is whatever it happens to be. And then we can use that gradient to work out how much light will bend. I'm going to put you over on this screen. So I'm actually looking towards the camera. That's better.
There you go.
Yeah.
We need some showmanship.
Yes. I mean, I can show you some refractive index measurements.
Yeah, the thing is, too, that's a huge concern is that, normally Snell's law applies to when it's going to two different medians. I know that we're talking about a slight change, but it's still air, right? The densities are a little bit different. So, I mean, we're not going to have nearly as much refraction as we would, let's say, going from air to water or water through glass, right?
Yep. Yes, correct. It's very small. Doesn't make a huge difference, but when you're looking over 50 miles, yeah, it could make a couple of 1,000 feet difference. What I was going to show you was some actual measurements of refractive index. May I ask, what is your nearest big city?
Yeah, that's going to be Tampa.
Tampa. I think I've got data for Tampa. One sec.
While you're pulling that up, I'm going to do a shout out. I didn't realize the YouTube chat was absolutely blowing up. I definitely appreciate everybody tuning in for the conversation. Yeah, we got KC Industry. He's a huge TikToker. He has like 100,000 following, so he's huge. We definitely appreciate you, buddy. Daryl Patton, Live Music, Byron, hey you. We appreciate everybody tuning in. Let's see if there's anybody I'm missing. Kim Ray. I don't think I've shouted you out yet.
KTW.
If some of y'all made it over from the Discord, we definitely appreciate it. We do stuff like this every week, so definitely tune in if you enjoy. They actually pulled away from their own debate, so I definitely appreciate Ruhif coming on. They're doing a moon landing debate over on the Tartaria Discord, so definitely a cool place to be.
I'm not going to be happy with them. Well, sorry, they're not going to be happy with me if I draw any viewers away. What was I going to do is share. I've got to share this screen now. One sec.
There's definitely room for everybody. By the way, KC, feel free to jump on in. Let me post the link again. King Shin, just saw your message as well. What is up, my friend? Ruhif and Adam are Globe Earth believers. And so they are trying to take me to task up here. We definitely appreciate them taking the time.
Giving my favorite refraction lecture now.
Sorry, man, I'm reading the comments right now.
Oh, let me check the YouTube. Hold on.
The comments are fantastic. We love the
refraction is our new god.
Yeah, refraction is a thing. Man. Refraction is a thing. All right, so this graph that I've got on screen, I probably should take a minute to explain it. So at every international airport around the world, they send up at least two weather balloons every day, and as they go up every few seconds or whatever, so they know the altitude. They take a temperature, a pressure, and a humidity reading at every couple of seconds. It could be every 50 to 100 meters, whatever. But at each of those samples, we take temperature, pressure, and humidity. Using those as inputs, we can work out the refractive index of air at each level. So at 50 meters, the refractive index would be X, and at 200 meters, some other refractive index higher up. From those two measurements at 50 meters and whatever, we can work out the average refractive gradient in that space. Okay, and this graph is what that is showing, the gradient as measured by these balloons every day. On screen is about a year's worth of data. It's probably 2020 or 2021's data. Now there are two series mapped on this graph. The red series are refractive gradients taken very, very close to the surface. So between the surface and say 60 meters or whatever, it doesn't matter what the distance is, but it's the first set of measurements close to the surface. That's the red series. The blue series are the first measurements above 100 meters. So you've got close to the surface and above the surface. All right, so the red close and the blue above the surface. Now this graph is like a histogram, like a frequency graph. So the taller peaks are the most common measurements. All right, so that blue peak in the middle is telling you this is really common for the refractive gradient to look like this. So if you look at the x-axis, it's around about minus 2.3. So that's the typical gradient because it's the highest peak, right? That's the most commonly occurring gradient. That is what we call the typical atmosphere, typical gradient. And that number, minus 2.3, I could probably show you how that converts into what you've probably seen as 7/6R. So yeah, this is where 7/6R comes from, is these measurements of the gradient, and taking that into account in the curve calculators as 7/6R.
Real quick, David, I appreciate your patience, man. Thanks for coming on the show. I love your
Hey,
I love your virtual background, man. That's sick. That's probably the best.
Cool.
That's the best best evidence of space, in my opinion.
It is. It's absolutely. I'm actually. This is the new annex on the space station that I'm at, and I'll tell it's. I'm overcome by these girls up here with the hairspray. It's got to quit. It's just so much of the freaking hairspray up here. It's Aquanet everywhere, man. I'm barged of it.
That's awesome. I did want to address Roof Hill's point real quick, and then I'll turn it over to you, David, since you just hopped on. Basically, what I would say is this, and I'll start with a question. It's, if we have this density gradient, and supposedly it's colder, it's more dense when it's colder, how come when we're actually seeing one of the examples of, heavy refraction and the FE core observation, we actually see that laser bending up and then shooting straight off into space, and that's
Bending
actually
up.
used. Yeah, and that's actually used by the globe proponents to be like, that's why you can see the laser observation instead of a point and shoot because of that effect right there. And don't get me wrong, I can kind of see that, but I'm just confused on the way that it's supposed to work, because I thought that it's supposed to bend down into the denser gradient.
Yeah.
So why is it bending up?
Typically,
and then going off into
typically
space?
light bends down. Yeah, typically, like on the graph, right? Whoops. So this graph on the x-axis, when the gradient is negative, so to the left of 0, that's light bending downwards. All right. So you'll see that once you get above 100 meters from the surface, then it's all bending downwards. Like all the blue is on the left of 0. So whenever you get above the surface, light is always bending down. And that frequent value of minus 2.2, 2.3 equates to 7/6R. The point that I want to make with the red series, so the red series is close to the surface. You'll see that spread out massively. All right, close to the surface, refraction can do anything. It still typically bends down, but it can bend up a little bit as well. If you had more accurate measurements really close to the surface, so these measurements are between the surface and the next measurement might be 50 meters, right? If you had that between 0 meters and 2 or 3 meters, you'd get a more accurate idea of what's happening really close to the surface. And you would see the red series spread even wider and more unpredictable. So what I want people to understand from these graphs is that the red tells you that close to the surface is unpredictable. The blue tells you that once you are above the surface by a decent height, light typically bends at 7/6R, but always bends downwards regardless. And you can use that to prove the globe, basically. So,
but okay, so
What?
I don't really think that answered my question. So we literally see, the question I asked was we see in one of the FE core experiments the laser bending up. You just claimed that the light will always bend down. I mean,
when you're above the surface by a decent amount, by 100 meters or so.
Yeah, I'm confused. on what effect would cause again, because we have the densest air on the bottom, right?
What's causing this
So why?
bending?
Yeah, so it's
The
supposed.
density
Well,
gradient.
in the FE core video, they started off with, and I know you disagree with me with the color of the lasers, but the color of the lasers does play a big role when you're doing long distances because the lights have different frequencies.
Right.
So and again, the if you have one that's at a red that's at a 400 and then a blue that's at, or a violet that's at a 700 or something like that, and you shoot it through the gradient, it's going to have a more, it not only it is more visible, right, but it's also going to bend more, and especially if you're doing it over longer distances, like you said earlier, right? So when they started out with a green laser, and the conditions weren't the same. It was in like a completely different time period. Conditions weren't the same at all.
Well, I think the analogy you're trying to draw is like Newton's prism, right? Coming from air into the glass, and it's actually splitting. And you're saying, you know, the red bends less, I think, on blue bends more, whatever. That doesn't really apply when you are already in the gradient with the light. The gradient.
So, now let me stop you there because they're not in the gradient.
Yes,
They're not in the same gradient. They're shooting they're shooting it over water though. So there's a denser gradient towards the water. And when they shoot it, it's always at a different elevation. The laser is always at a different elevation, and the observer height is always at the same elevation. Is this true or false, Skylar?
So from what I understood, they did it from a consistent height. The laser part, they did it from a consistent height of, I believe, 2 or 3 feet above the thing. I'll have to look at it what it was exactly, but it was lower.
It was
than
1.2 meters observer height, and then 9 meters. It goes all the way up to 9 and 10 meters for the laser height, if I'm not mistaken. So the laser height always changed, and the observer height always stood the same.
No, they did. So that part I know you're incorrect on, because what they ended up doing was and this is one of the complaints from the Globe side, just to give it to them, is that what happened was they were trying to do a point and shoot type experiment where they actually hit a target with the laser, and they ended up doing it with instead of that, they did a observation where they were able to just see the laser from a observer height. It was the average. It was I think it was like 5'5". It wasn't very high, but still, it was what it was on that particular one. That's just the one I'm remembering. The other ones, I'm sure they had. I think they had to redo it because they were having issues with their, with the refractive index. Again, with the laser obviously bending up into space. They knew that wasn't going to be conducive for something that would falsify the Globe model.
Right. Their understanding of refraction was atrocious. FE core. Absolutely atrocious. The way they did refraction was, let's take a measurement of the air on one side of the lake, and let's take a measurement of the air on the other side of the lake, and then just see that they're almost the same, and therefore the light's not bending at all, right? That's terrible. That's not how refraction works at all. Refraction works off the vertical gradient. So you got more dense at the surface, less dense higher up. That's what causes refraction. It's not, one side of the lake versus the other side of the lake. That was absurd.
The thing that I think also
embarrassing.
I find hilarious about the whole duct theory that the Globe has is that we have to assume, I know that you're saying that when over 50 miles, 100 miles, it could definitely make that a thing. But some of the observations that we have are just over like 15 miles. And basically we have to believe, if that's the case, that the light is shooting all the way up into the sky, hitting this patch of warmer air, and which we all know that that's not conducive. The higher up you go, the colder it gets, until you get, supposedly to the thermosphere or whatever, where it starts to get really freaking hot. But in my experience, up on the top of mountains and stuff, it's cold. So
yeah,
we're expecting the light that's going from a cold median, a dense median, shooting out into space because of the curvature of the Earth, even though it's only like 15 miles, and then bending back down to the observer's eye, all to give us the illusion of this, flat level plane in front of us. It just seems it seems really fantastic, you know, and I still haven't
The
been able to
fact that it
see.
bends downwards.
I have
What's
not
the
seen.
contention there?
So for one, it's not bending. It's not having a severe refraction through different changes of medium. It's just different air. The amount of distance that we're expecting the light to travel between us and the observation doesn't make a whole lot of sense to me either, because how high up is this band of hot air from the cold air that the observation point is starting at? You have to expect
Hang on,
it to travel so
describe.
far up, and then it has to travel all the way back down. So it's basically making this big triangle to the observer.
Oh, curve makes it curve. But you mentioned cold air and hot air. Like, what's the arrangement of the cold air and the hot air?
So for the duct effect to work, at least from the diagrams that I've seen, you have cold air on the ground, hot
Yep.
air above the cold air, and then that's all that's really necessary. I
Yeah.
guess you could add a whole
That
nother
will
layer of
give
cold
you,
above that, but
doesn't matter. That will give you, yes, much stronger than average refraction. Yes, but even without a temperature inversion, you still get downward refraction. Like, if you still have warm air at the surface and cooler air above, due to the pressure gradient, you'll still get downward refraction. The gradient, the temperature gradient you need to change it from downward refraction to upward refraction is about 34 degrees Celsius, so 34 kelvins per kilometer, right? So if you have a temperature of 20 degrees Celsius at the surface, for light to bend upwards, it would have to go to minus 14 degrees Celsius at a kilometer above you. Right? That's an extreme temperature gradient. And those extreme gradients really only happen close to the surface. So you really only get upwardly bending close to the surface.
right, but it still doesn't address the fact that we're still having the light present itself. It's bending up over obstruction, which we still haven't even seen with air done. I mean, I can imagine it being done with water and glass, because I've seen the whole effect of the guy who's sitting in the pool and his head's above the water. He's looking right at you, but the refraction of the water and the glass makes it look like his body's turned completely around. And as you move across the pool, you'll see that it's actually nothing wrong with him. It's just the way that the light is bending. I get that,
Right.
because we have that's literally two different mediums. And in every other sense of the word, usually when we talk about two different mediums, it's like two different substances, things of completely different densities. We're talking about cold air going to slightly warmer air. Is there any
Yes.
real world demonstration of light being able to, just using air and denser air, bending up over obstructions?
Yeah, Jesse Gordon's done that. I'd have to find his video.
Wouldn't this play hell on a lot of military laser guidance systems, laser targeting systems, like especially at sea, where we have a lot of different weather patterns happening and densities of air mixing over the. I think that would play that the difference between completely missing another battleship and hitting it,
No, but the laser range, or the laser targeting, right, paints a target with a laser on the ship, and your missile is simply looking for the reflection of that signal.
Well,
So it
that's
doesn't
what I'm
matter if
saying.
it's
You got to be
refracted.
able to hit the ship with the laser. So if the thing's curving up or curving down, so you have to make adjustments for that.
No. If you can see the ship with light, right, then your missile will just see the reflection of that light. So it doesn't matter for targeting. The point there is, can you see it in the first place? So that's a curvature issue. Can your light get over and see the target?
Well, that's the point that is being made, because like if you're wanting to hit the water line of a ship, for instance, and it's say 50 miles away, that's a hell of a lot of curvature in between you and the hull of that ship.
Yeah.
You see, so you would never be able to paint it.
Yeah, that's the question.
Yeah, well, it's not a question.
It's not a targeting
it's not
issue.
really a question. It's an absurdity that can't be proved. That would indicate that, well, there is no curve. There couldn't be a curve, or that would never be able to occur.
No,
right?
Again, you're ignoring the fact that light bends through a gradient.
No. It's not going to bend like that. It's not going to bend 30 or 40 feet around a curve. I'm sorry. It's just not going to do that. And gravity's not going to grab light either.
No,
None of that's going to happen, man.
Well, the conditions that need to exist for light to bend at the same rate as the curvature of the Earth do exist close to the surface, measurably exist.
No. No,
Yes,
it
measurable.
doesn't. Otherwise, that curvature would be evident all the way and be consistent.
See,
It would
see the
have.
graph.
So let me ask you a question, David. If I shoot a laser through a 3-foot fish tank and I watch it bend 3 inches through a 3-foot fish tank, 2 inches through a 3-foot fish, and you scale that up onto an atmosphere,
You'll see
right?
it angle. You won't see it bend. You'll see it angle.
No, you see
No, you
it
see it
bend,
bend. See it
David.
curve.
It bends.
Okay.
Yeah.
It bends.
Light curves through a
Right.
density gradient. Oh,
Okay.
you've seen.
So are
you've
we
seen
shooting it?
lasers
We're not
through-
shooting the water through water. We're not shooting the laser through water. Or
I
curve
understand,
either.
but
We're
so
going straight out over
so what
across
I'm talking
the room.
about, is if you shoot laser through water, it'll go straight. And if you add a density gradient to it, like sugar, and this is something that we addressed the last time that I was on
It'll
the show,
diffuse it. Yeah.
it'll make the laser bend radically, and it's because the sugar creates density at the bottom, and as soon as you put that laser through that density, the laser moves towards the more dense gradient, so it goes down. It's denser down towards the bottom. So if we have denser air close to the surface, the whatever light laser, doesn't matter what type of light it is, it's going to bend around the surface of the Earth. Now, how far will the light reach? That's the question. That's what
Yeah.
what
That
Roof
depends.
is trying to get at.
Yeah, and that depends on the gradient, right? So that graph that I posted before of Tampa Bay near Troubling Tribune, I cut off the x-axis on the left at -6, right? But if that x-axis went to -16, right, that is the same as light bending at the same rate as the curvature of the Earth. And those conditions do measurably exist.
But we're not seeing a physical curvature. That's the point. Your light can do anything through a lens that you want it to do. It doesn't mean that it's following a curvature of a plane. I can take a lens of any kind and do all kinds of funky shit with light, depending on the density and the gradient. I've been out in Death Valley in the driest environment known, and I've done these types of tests, and I found that there's absolutely no air density that's screwing with my measurements whatsoever, man.
Did you make measurements of the temperature, pressure, and humidity?
Well, yeah. I mean, it's like it was like 115 degrees.
Well,
You know, I mean,
No,
what I'm
vertical.
well, then
getting
there's
at, what I'm-
definitely
what
going to
I'm
be
getting at,
that
that seems like a hell of a
heat will
lot
mess
of
with the
bullshit
light.
to put your mind through to convince yourself that you live on a curve, when a simpler observation than trying to make a light bend around a damn ball, which it's not doing. It seems to me that the simplest observation of what the curvature calculation should be at a certain distance would be sufficient to prove that there's no curvature, up to and including over 100 years ago when Samuel Rowbotham did it.
Okay. Did you make a measurement of the gradient? So not just a single measurement at ground level, saying it's 115 degrees.
Right.
Did you
The
measure
point,
the gradient?
the point being is we didn't have the refraction like you're talking about over a lake. We had one of the driest environments known. Humidity down to less than 5%.
Cool. So you've got no humidity gradient.
So
that helps
that's
me.
right.
That makes refraction
Absolutely.
stronger.
And so the density of the air would matter not much at all as far as that's concerned there, because we're not looking through a thick medium anymore.
If you don't, if
but
let's
you're
say
talking
at
about
surface,
density, temperature, and pressure, though.
Mm-hmm.
Hang
It
on.
doesn't
If-
matter. That's
Yes,
a
it does.
lensatic effect. It's
It
not
does.
a
It does. If
curvature.
you're shooting it over water, the air is going to be cooler over the water.
I'm not shooting over water. I'm shooting
doesn't
over a
matter.
fucking dry, dead lake bed, bro.
Was there a
Then you're-
vertical
okay.
humidity gradient? So you said it was 5% at the surface. Did it go to 0 higher up?
Well, I don't know. I didn't go up, and it wouldn't matter.
Yes, it
would be-
does.
no, it doesn't. That's not
Yes, it
showing a
does.
curve of an Earth. That's showing a lensatic effect. Lensatic
If-
effect is not the curve of the Earth.
If you don't have measurements of the vertical gradient, you would have no idea how much
7.9
light
inches
bends.
per mile squared. There it is, man.
The vertical gradient, I feel, matters a lot less because, again, we're not shooting the light up. It's being shot
No,
across perpendicular. You're
Think that
assuming
the weight-
that because
weight
the Earth
of
is
it
curved,
pushing the
that it's
light
going to-
down or something.
well,
No,
you're
the vertical gradient is the only thing that matters, right? If you shoot horizontally through a vertical gradient, I will tell you how much light will bend.
I feel like regardless of what we say, you will simply say that the observation fits best for the globe. So
I haven't
basically
seen his observation, but
Yeah,
he
but
made
I,
no
the
I kind of
refraction
measurements of
feel
the
like
gradient.
this is incredulity on you guys' end as well.
Yeah,
Well,
there's
the
no
thing- the
measurements
problem
of
It's
is-
something
gradient.
that you don't
John,
understand, that you
you
don't
do
want to
realize-
accept.
Adam, you do realize that the globe is the claim, okay?
Right.
That's the claim that requires proof. And a laser
Don't shift the
shot
burden
over
of
a
proof.
lake
Don't
is
do that.
not
Don't do that.
I'm
You're
happy to
shifting the
accept the
burden of
burden.
proof. Do not,
I'm happy to accept the burden.
That's not shifting the burden of proof. All observations of anyone with any common sense, when you go out, if nobody had ever told you you lived on a spinning ball, you would have never come to that idea yourself. Never.
but
I've
we
got a
did
question.
though.
You would have
We
never
did
ever
as
entertained the
humankind. We
idea.
did.
Because
I've got a
everyone in your
question. As humankind, we
senses
did.
tells you that you're stationary, not moving, and level.
I got a
Before
question
As
for
a
we-
David,
human
right?
race, we did.
Before we
We
accept,
question
we
for
came
David.
to this conclusion.
hey, before we accept
Question.
Ruhil's globe proof, since he happily accepted the burden, I will just say that the refraction does create a problem because, again, it's creating this illusion, this persistent illusion that we live on this flat plane, even though we actually live on a ball with a set radius. The problem with that is that, again, if the globe is the claim, the falsification of it basically becomes impossible once you introduce refraction. And I know this because I've showed several examples of long distance observations in the past, and people with literally not knowing anything about it will simply say refraction as an answer, even if it didn't need an answer. So it's a little bit of an intellectual honesty test. So I would just leave the refraction on that part right there. And yeah, Ruhil, I'll happily accept your evidence. Ruhil,
I
sorry.
love.
I'm terrible with
the long
names, so-
distance. That's all right. I love the long distance, like beyond horizons photos. Perfect. Anyway, so my question for David was, so like assume flat Earth, and I think you would say that light doesn't bend, or does bend.
Are you talking to me?
Yeah. Do you accept that light bends?
I would
density
accept
gradient?
that light bends as a result of a lensatic effect. I do not accept the fact that light bends because of of gravity or a curve or time, space, or any other such nonsense like that.
Cool.
Of course, light bends with a lensatic effect. That's how a prism works. That's how most army tanks used to have to navigate around as they looked through a prism.
All right. Does light bend through the atmosphere?
We bend light. We use periscopes and bend light in images all the time. We bend light using the GoPro camera. This is still not any evidence of a globe at all.
Okay.
It's just a lens and a light.
Does light bend through the atmosphere?
Yeah,
Through
I'm
our
sure
air?
that it can. Through the atmosphere
can.
plane, I do believe that it does. Yeah.
Do
It
you
can,
have an
but
idea of
not
which
to a
direction?
not to a significant degree to show
Okay.
a 7.9 inch per mile squared curve.
Okay, cool. So we'll assume little to no refraction through the atmosphere. So my question to you then is, if we are on a mountain and we have a camera, or we have a theodolite, we have an angle measuring device set up at 1,000 meters above sea level, right? And we are looking across to another mountain, 20 kilometers away, whatever it is. It's also at 1,000 meters above sea level. On a flat Earth, what angle should we measure if light doesn't bend significantly? So we're at the same elevation.
Well, I would imagine it'd be 0 degrees, man.
I agree. 100% agree. It should be 0 degrees. Okay.
And how far away is it?
20
20
kilometers.
kilometers?
20 kilometers. Yeah.
Let's run that.
It doesn't really matter. Yeah.
We'll run that calculation though to find what the curvature should be.
Yes. Actually, yeah, let's do that. Yeah. So we're 20 kilometers away. How much drop should there be?
So what's 20 kilometers in English in reality?
13, something like that. Hang on. 12.43. 12.43 miles.
4.43 miles is
12.
20 kilometers.
12.43.
Oh, 12. We'll say 12.5 just for the hell of it. Times
Let's do it imperial. 12.5 miles.
equals.
All right, amount of drop, about 100 feet.
104 feet.
Okay, that's geometric without refraction, but we'll go with the geometric result for now.
And don't forget gravity.
No, gravity for our intents and purposes, gravity doesn't affect light, right? That's such a minuscule, irrelevant.
Hey, I'm still listening. I just had to step away for a second. I'll be right back.
Yeah. Cool. If we did some trigonometry, right, and we had a triangle that was 104 feet for the opposite side, and the hypotenuse was our 12.5 miles, right, we would come up with an angle, right?
Mm-hmm.
It'd be a pretty small angle, like looking down 100 feet over 12 miles. It'd be a small angle, right? If the Earth was curved and that drop of 104 feet was actually there, then I would predict that's the angle we would measure with the theodolite. Yeah.
Okay.
Cool. Guess what I've done?
What?
Gone out and measured angles.
Cool.
Yeah.
So this is what I'm wondering: how come at a distance of miles beyond what we can see, what we're supposedly where the curve would be, when we use a telephoto lens and we pull the object into view, and there's yet even more horizon and ocean behind the object, and I'm referring to, for instance, the Black Swan oil rig photographs. Is that a result of refraction, putting that image up over a curve where that thing should be like, you really think that the light is bending an image up tens to hundreds of feet into your view, David, to fool you?
Look at the picture.
Hold on. And that's what fools you into not thinking you're on a ball. That's a lot of fucking hoops to jump through, bro.
No,
it really is. When the obvious answer is there's no curve. There's the obvious answer. Occam's razor, bro.
The video that came from BMLSB 69, right? He went to that same location for 3 months and took photos of those oil rigs. And he shows the typical situation, which is that the far oil platform is below the horizon 69 times out of 70 or whatever it was, right?
Well, how are we seeing it? You mean actually the horizon itself beyond the object that should be hidden is refracting up to make me think that it's level. That's what you're saying.
In the Black Swan, yes.
In the Black Swan, in all of these objects, all of these things that we've seen.
Yes. Typically not, but yes.
All the way from the hull up, we can see them, but that's because of refraction. I'm sorry, my friend, Mr. Rubin.
Let me get in. Let me get in on this, David.
You're full of shit.
You can be incredulous. That's okay.
I'm sorry. There's no other way to put it. You're as full of shit as a Christmas good.
The last time that I was on the podcast, Skylar told me that I was seeing heat rays because I'm looking at crooked cranes coming out of it, okay? And he also told me that on a regular day, the pictures that we're taking, that those pictures are pictures of the refraction happening. That's what he told me.
Sorry, the normal days, the typical days, like the
no. I'm addressing David.
Listen, you are going to have.
No, you're telling me that it can't bend it down, but it can bend it up to where it's not seen. You're telling me that it can do the opposite effect. But I'm telling you that this is what people in your community have told me.
Well, I don't.
So you're not believing that it can bend it. Well, I'm my own in the flat Earth community in general. So
what I'm saying is this.
So you're telling me that it can't bend down, and we can't see the curve, right, because of refraction. There's no way that light can bend like that. But other people from the community are telling me that on a regular day, when it's hidden behind the horizon, that's really refraction happening. That's a silly argument.
I don't know who you've talked to, but I've never heard that at all.
Skylar from Tribune.
Listen for a second, Adam. I only got a couple of minutes left on here. There are conditions with atmospheric opacity and a lot of times with wave height that will diminish some of your view at that distance. It's real simple like this. You can see my face real good right here, can't you? Like that. Let me bring it up real close. See my finger blocking my entire fucking face in view? It's the same type of a situation that goes on right there, and it has to do with atmospheric opacity. Nothing is bending an image and putting it hundreds of feet above what you would consider to be a curve. That's ridiculous. Do you realize what kind of shit that would play on visual aeronautics even? I mean, that's just that doesn't even make any sense. And it's a lot of hoops to jump through to make a person believe that, oh, All of my senses are completely wrong. My eyesight's wrong. I don't feel things. Don't feel myself spinning in all these incredible fucking speeds through the universe because of math. And I can't believe what I see at all because somebody else came up with well, you see here, this light will do this, that, and the other. And it's like, no, man, that's not what's happening. That's a lot of fucking excuses to cover for the reality of what you see.
Okay, question.
Your actual senses are not wrong.
Hang on.
Your actual
Have you seen
there are
Black
hundreds
Swan
of photos of the oil rigs that are perfectly fine, that are covered by the curvature. And there is one picture of the Black Swan oil rigs where you can
see
any
curvature, Adam. There's no curvature.
There's one picture.
How am I seeing horizon beyond it? I'm seeing a horizon beyond it.
David, listen. There is one picture of a heavily refracted oil rigs. And you're telling me the atmospheric opacity, it can happen every now and again, but there are more pictures of the regular oil rigs being hidden by the curvature than there are of the one picture of the Black Swan incident of the light being refracted. You can clearly see
I have an entire playlist of objects over the curve being brought back into view, full view in all weather conditions from different locations, not just oil rigs, ships, small sailboats, all kinds of things. And it's not being refracted up over a goddamn curve.
Just a quick question.
You think, wow, you really got to snow yourself. You really have to snow yourself to believe that shit.
Question.
You really do.
Have you seen the Black Swan compared to the typical day? Have you seen those side by side?
So only on some days the Earth is curved.
Okay. Have you seen that comparison of the typical day versus the Black Swan?
No, yes. I don't. Probably. I've seen a lot.
Okay.
Look, I've been in this game for 10 years. None of your flim flam works on me, bro.
No, I'm just trying to get to a question.
Flim flam works. I've been through this. Ain't my first rodeo, cowboy.
Why do we?
I'm just trying to get to a question.
So I gotta interject for a second on your question. Now, why do we assume that is the regular picture? Besides, of course, that there's no heat waves present. That this is the typical. This is what it always is. Yeah. The claim is that there's thousands of pictures or hundreds of pictures of these oil rigs, and I've only found a couple, and they're all related to the FE debate. So I'm wondering, where are these thousands of pictures of these oil rigs?
Okay, so like I said before, BMLSB went there, over a period of 3 months and took a photo almost every day. So the typical photo is that the far oil rig is obstructed by the horizon. That's the typical photo. Now, the question for David is whether he has seen the typical photo where the further oil rig is obstructed compared to the Black Swan. Have you seen that comparison?
So have I seen a picture of the obscured by atmospheric opacity as opposed to one shown
by whatever
your day? Of course.
Okay.
Why? Who hasn't? Is that proof of that? Is not proof of a curve at all.
No, I'm getting to my question. If you have seen that comparison and I ask you, does light bend? What will you say?
Well, I said that light will bend as a result of atmospheric lensing. We know this, but it's not going to refract an entire fucking image the size of an oil rig to where it's above the curve of the Earth, as you say, and I still see more supposed curve of the Earth beyond it. That's the most ridiculous thing in the world.
I think we covered a lot of ground.
Show me an example. Do it. Show me an example. Refract an image up over from behind something so that it looks like it's sitting on top of it. Do it.
The point of my question is that if you have seen that comparison, you will see the relative difference between the back oil rig in the typical photo and the back oil rig in the Black Swan photo. You will see the difference in their position. You accept that refraction can move it from one of those positions to the other.
No, I'm not saying refraction. I'm saying a lensing effect of atmospheric opacity, dude. It's a lensing effect.
Another word for
if you're looking through more water or less water, it's the same thing as looking through glass, bro. It's going to either magnify or it's going to or put it out at a further distance. This is one of the reasons that out in Death Valley and in the Mojave Desert, you can see so much further than you can here in the east. I go on a mountain here in the Blue Ridge Mountains and I look and I can only see for maybe 20 miles. I do the same thing out in Death Valley. I can see for almost hundreds of miles, man.
Right. My point is that if you have seen that comparison, you must accept that the atmosphere can change the apparent position of an object. You must accept that.
This way it can't.
No, this way.
This way. No.
This way, yes.
No.
But you have not seen the comparison.
Not by hundreds of feet. No fucking way.
If you've seen that comparison, if you actually
can show me an experiment where you can prove you put an object behind something and give me the refraction and show it above the fucking object. Show it to me. And I'm not talking about
comparison.
Some
you must
accept picture. Do the goddamn experiment.
If you've seen that comparison, the relative position of the back oil rig changes with respect to the oil rig at the front.
One goes, it's up higher in the air?
Yes.
Bullshit.
Hey, I gotta cut you off for a second because I am doing this in I'm doing this in Google Meet. So it's probably gonna boot us here in just a second. The show is not over. I'm gonna start another call immediately. I'm gonna drop the link. Ruhif, David, please come back on. And we'll keep this show rolling. Alrighty, folks, just give me one moment, and we will continue the show. The heck? Get me in the meeting. Let's do it. All right, just create a meeting for later. Whoops, starting an instant meeting. Let's get this. Where there is a will, there is a way. I have found a way. We'll get these guests right back in here. Boom. Alrighty, let me just get this to the chat. This will take me just a moment. Okay. Let us go over to... Alright, sorry. Took a little bit too mellow of a break. Let's get this. Dropping the link now. Boom. There it is for the YouTube. Here it is for the Rokfin. Boom. All right. We're off and kicking. Let's get them back in here. Yep. View all. Admit. Admit. Welcome back.
Whoa.
Let's see if David comes back in here as well. And guys, I just shared the link. Feel free to hop on in. It looks like I don't know even how many guests I can accept in here, but there's room for everybody. So we got a great panel tonight.
Man, I don't know if we'll get to touch celestial navigation, man.
Oh, we will.
Oh, Cell Nav. Yeah, I won't actually. No, I've only got like 35, 40 minutes.
No worries. I don't need any whiteboard ideas.
All right. Yeah, but Cell Nav would be great. I did a debate with, Nathan Oakley, the Flat Earth debate crew.
Oh, yeah.
Yes.
Yeah, I did a debate with one of those guys about 6 months ago on celestial navigation. It was fantastic.
Oh, nice. Awesome.
A lot of fun. Yeah.
Be awesome, man. I've been learning a lot, man.
All righty, David, coming back in.
Boom. I've asked the Discord people over on Cosmology Tartaria to try and find the photo comparison between the Black Swan and just the typical photo, and you'll see that the Black Swan,
it's Platform Hill House. Just Google that.
Yeah, whatever the back one is. Yeah, the rear one is relative to the front one is shifted significantly upwards. All right. So if you've seen that, you have to accept that the atmosphere can change the relative position of objects.
Yeah. Well, we showed that on the last podcast.
Okay.
Somebody, Austin Murphy, it should be working. We just had everybody join up, no problem. So
Yeah, it works.
yeah, it should be working just fine.
We didn't quite get to my point with the theodolite measurements.
You know what? I would like you to repeat that because Skylar stepped away. But
Okay.
this will go back to the point that I tried to make the last time. If you take a theodolite and you shoot it out, right, you're creating a tangent line, and this is what the math is based on when you look at the curve calculators, right? So you're
Austin Murphy,
curve
welcome to the show,
calculators-
man. I see you figured it out.
It took me a minute, man. It's a little more complicated than just pushing a link. You got to download the app, and then you got to figure out how to type in or where to type in the code. And
Oh, weird. I'm doing it all in browser, so
I'm in browser
Yeah.
as well. Okay.
yeah, I've never used this
are you on a cell
platform
phone?
before. What's up, man?
Are you on a cell phone?
Yes, sir.
Yep, that's probably why.
Can you guys see me right now? I don't know if you
Oh,
can
yeah, you
see me.
You're good.
Oh, okay. Yeah, I don't know. I've never used this platform before. Usually just StreamYard. So
It was a little too hefty on my computer, so I did the Google Hangout because it's a lot less beefy, and people can still present. We have had very few audio issues, and people can connect easy. So right now, I think it's a win.
right on, man. Well, thank you for having me on.
Oh, there we go.
Kind of just
All right, let me
wanted
take
to
some
hang out.
screenshots.
Mr.
Did
David.
Yeah, I mean it. I had to search around, man. I went warp speed around that little planet back over there. And I almost hit the fucking thing because the light was refracting and made it appear like it was in a different spot. Thanks a lot, Ruhif, for your refraction. I almost hit that fucking planet back there.
Oh, David. Sovereign.
What's happening, Mr. Austin Murphy?
What's up, man?
I'm up here piloting the old starship, flying around, dodging refraction, gravitons. There was a graviton came right through, almost broke my windshield a little while ago, man. It was some fucking shit. I couldn't believe it. It blew me half away. But I got the force. I'm using the force and shit.
All right, can you see my screen?
Yep, we got you.
All right, can you see that the back one, platform Hill House, wasn't it? Can you see it change relative position to the front one?
Yeah.
See the helipad on top?
Yeah.
That changes relative position to like where it intersects with the front.
That would be assuming we've taken these pictures from the same spot too. I don't
Yes.
believe they were.
Well, you have to take it up with BMLSB, who says they were.
I don't need to
so-
take it up with anybody. I'm just saying they could be taken from completely different spots.
They're not. You can watch the video.
Like watching the video right now
One has swell, one doesn't.
doesn't tell me
Tons
where
of
they're
explanations.
standing at. One could be fucking mile closer. The other one could be a mile back. Who knows?
You can call the black
Hey,
swan.
listen, this is the thing I've
learned.
learned about you globies, man. You're the
not
most
my footage.
deceptive and dishonest people I've ever run across in my life. You
This
are.
is not my footage. This is
You know,
not my
I know,
footage.
I know it's not. I know it's not. What I'm getting at is that I have found that you globies are the most deceptive. You'll go
Yeah,
through the
and you're a
most
fucking retard.
preposterous
Flat Earthers are the most
horseshit for your
retarded
stuff to
people,
be
right?
true.
We can
You'll go
just
through the
throw
most
insults.
preposterous bullshit. When you know what would be the easiest thing?
Right. We can throw insults, and I can just call you a retard, right?
I'm not.
Or we can
I'm
look
not
at the
insulting.
evidence.
I'm just saying you guys do. You
You're
go
calling
through
me
the most
dishonest. You can get
preposterous
fucked,
fucking
right?
shit I've
You can
ever
get
seen in
fucked.
my life.
We can
to
look
try
at the
to make
evidence. We can
something
get fucked.
ridiculous be true. It
All
is
right, anyway.
fucking hilarious, man.
Okay, you're retarded, and I'm dishonest. All right, we agree.
Whatever, man.
Okay.
I'm retarded. I don't care. Your
Okay,
perceptions
all right.
don't mean shit.
Anyway,
to me.
let's not.
The
Let's
late
not.
night
See,
show.
because I know I'm fucking right. I know I'm right.
Okay.
You know you're not.
Okay.
You know you're deceptive.
Well, anyway,
You know you're
looking at these
deceptive, dude.
images.
No. That's not that. You know you're willingly
Okay.
deceptive. You know you are because
Okay,
no one
and you're
would have
willingly
a fucking
retarded.
brain.
You're the most retarded
No one with
person
half
on
a
earth.
fucking brain would jump through that many
All right,
fucking
guys.
hoops. You
Okay,
make something
yeah, let's
ridiculous.
let's
be
reel it
true.
back.
Come on.
Yep.
Come on.
It's
Progress.
useless, right?
Let's progress the conversation and not talk in circles. It's fun.
Yeah, it's just pointless
can-
going there.
We can be spicy for here and there, but let's try not to make the whole show about it, right?
Yeah. All right. Anyway, we can see with these images that the back platform changes its relative position.
Were you able to pull
I
up
don't know.
Were you able to pull up an example of like in a lab or something like that of the light bending up over an obstruction?
Jesse Gordon, I've got to find his videos though. I can get you his channel.
If you could show us an example, because I've actually scoured for that, and maybe my algorithm just doesn't favor me, right? If you could show us something like that, then that would be crazy. I have not seen that.
Hey, Troubling, my son taught me a cool thing. When you're doing searches, you get more accurate results if you put what you're searching for in quotation marks.
Oh, because then you get the quotes of people talking about it.
He was showing me that. He does that all the time, and he gets different results when he does that, man. Wow, where'd those things go? Jeff, easy. I'm new to this platform. I don't even know how this thing works.
I know it's different to me too. I'm like, what the heck?
How come you're not using StreamYard, Trouble?
It's too hefty on the computer. When I was using the Restream, which is pretty much the same thing, I had horrible audio issues, and so
really,
yeah, so I switched it up to the Google Meet, and now everything is working pretty smooth. So at least until I get a better computer, this will be the way.
What was the question? What was the question I've got to look for?
Oh, we're looking for an example of light bending up over an obstruction to present itself flat and level in a controlled environment, like a lab or a box or something. Yeah. Instead of just assuming that it's happening because of the curvature of the Earth and we shouldn't see it, let's actually see it in the lab setting. That way we can verify the cause of the effect.
Okay, I'll have to go through his videos. He's got a video here where he has a Theodolite set up looking horizontally at a sign that's really, really close, and he can see a ship above that, above the crosshairs, right, which is demonstrating that light's obviously bending downwards. So yeah, it's a 15-minute video, so we can't really do that.
That kind of whole thing hinges to me on an assumption, because the way that it would work on a flat Earth model is that the horizon's just rising up to eye level. You got a ship over in the background. Of course, I haven't seen it. Maybe it's something like way, way off in the distance, in which I'd have to see how close the sign is.
I know the one he's talking about. And I've actually taken stills from that and increased the gamma and reduced the gamma. And what you can see is that the horizon is actually beyond the ship. It's being obstructed by the way the light is. When you change the gamma, you can actually look and you'll see that the horizon is back beyond the ship. That it's only an optical illusion due to the brightness of the camera. It's all.
Yeah, but we're not concerned about the horizon. It's just that the boat appears above the crosshairs. That's the point.
Yeah,
whether the crosshairs have to do with anything. If I move the camera lens down like that, now the crosshairs are down here. That's the horizon is everything.
No,
the horizon is demonstrating. If I'm seeing horizon beyond a boat that's supposed to be over a curve, that's ridiculous.
Right. This is demonstrating that something that is clearly below you on both models can appear above you. Right?
Well, wait a minute, you're clearly below you. You're with the assumption that you're on a ball.
No,
it's not clearly below you at all. It's clearly away from you. There's no below about it. Everything shrinks into the horizon from the bottom up to the vanishing point. That's how your angular perspective of your vision works, man. They teach you that in art class in 7th grade, man.
On either model, the water level is below you. On either model. But in this video, it is above the crosshairs. That's the point.
Well, the horizon's always going to be at eye level, regardless of the altitude that you go. Yes.
Do you want to put money on that?
Look down to see the horizon. You
So
would
say
have
that
to
again?
look down in an airplane to see the horizon. You don't. You look straight out, and there it is.
How much money do you want to bet on that?
Is-
do you want
is
to know how many
life
measurements of
savings.
the horizon I've made?
I
I've
don't
literally.
I
made
don't know
1,000
what
measurements.
you've done. I know that you think that a fucking some kind of refraction can put an object like that, lift it up in the air or some kind of shit to your vision, when clearly it doesn't, because we see more horizon beyond the distant object right there.
Okay, let me just bring up a single measurement that I've done. All right. Is that sharing now?
I measured this right here and I found out that it's 80 cubits, but it only appears to you to be about 4 inches long.
Okay, but see what I've got on screen?
The refraction.
That's my Theodolite measuring the angle to the horizon. It is measurably not at eye level.
That's not the horizon, bro. You got it lower.
Yes, it is.
No, it's not. That's
Yes, it is. What? It's literally me measuring the horizon.
your apparent horizon.
Whatever horizon.
I see you got I see you have the thing on a sandbar, but I see other shit beyond that sandbar that point is on, indicating that you've actually got it not at 90 degrees.
It's that 0.2,
This
man.
is a photo.
0.2.
This is a photo of the Theodolite screen showing the angle, right? The telescope is pointed at the horizon, which I can bring up a photo of as well if you like. Hold on. That would be.
Are we, just so I'm clear, are we saying that the horizon is below or above the crosshair?
It's below eye level, below horizontal.
That blurry thing you see there is supposed to be the horizon.
It might just be
Does this
clouds
video
I'm looking
work?
at,
Let
but
me
it
just
kind of looks
see if
like
this video works.
I'm seeing that it's above the Theodolite, but might just be
All right,
clouds.
see, look, there are the crosshairs on the horizon, and there it is, greater than 90 degrees. All right, did you see that?
No, only for a second.
Yeah, so the crosshairs are on the horizon.
Yeah,
and the angle down to the horizon greater than 90 degrees.
What?
From vertical, obviously.
That's level straight out, bro.
No, it's not.
Proof.
It's a third of a degree. It's a third of a degree lower. I've made probably 1,000 measurements of the horizon, close to 1,000. I take my fucking gear out for fun.
So we can't play with the levels in that image there and possibly be able to pull up more horizon above that line, would we?
You can try. Do you want to take a screen grab of that, or I'll take a screen grab? Hold on.
Well, David, you said you've done it before, so I was going to let you do it. That's a bit above my expertise.
Look, that thing's straight out, man.
No,
That's
it's not.
You're going. Yes. Listen.
No, it's not.
I've seen this trick. I said, listen, hold up a second, Ruhib. I've seen this before. You're at 90 degrees. You're not looking down.
Yes, 90 degrees, 21 minutes and 42 seconds. It's down.
Why didn't you just go ahead and hold on, pull up the back with the crosshairs again, because that little minuscule 2 right there that you got is horse shit for where you got this visually. Look at that. Look at it. It's actually below it. It's actually below the fucking horizon. You've got it below the horizon, bro. Look at the left-hand crosshair. It's below the fucking horizon.
No, that's where you see things in the middle. So if there's a thing that you turn left to right, yeah, so you can see that it's in the middle. The angle, so the angle that I'm measuring, right? 21.
Did you zoom it in any? Did you bother zooming in any on the ship?
No. Let me give you an idea.
Why not? That would have been the honest thing to do, because then you'd see that it stays.
You're a retard. Stop calling me dishonest, you fucking retard. All right.
Well,
as soon as you call me dishonest, I'm going to call you a fucking retard. All right. Because you're fucking retarded. All right. You're trying. You're an idiot, flat earther, fucking retarded. All right.
No, what you're showing is fraudulent.
Yeah, because you're fucking retarded, right?
No.
Yeah,
no,
okay.
because
let's stop.
You only think I'm retarded because I see through your bullshit.
No. I'm only calling you retarded because you're calling me dishonest, right?
Well,
so let's
it's a retard.
Let's stop this shit.
It's a retard calling someone else retarded. The
Okay.
retard
Anyway.
doesn't know that they are the retarded one. It's hilarious. I fucking
But
love it.
I don't get it though.
Let's
When,
not.
when
How far
someone
away
when
is the
someone
Alright, guys.
provides
Rohit?
when someone goes
Let's
out
not.
and they get out in the field and they do experimentation, y'all
Yeah.
just sit there and say that they're being dishonest. You completely deny the proof. You
Well,
completely deny the
Adam, I've
evidence that's
done it.
presented.
I've done
Hold on.
the experiments. I've done the experiments.
Where are they?
Okay.
Can
So
we finish this first? Let's finish
listen,
this.
like I said, this ain't my first rodeo,
You see my
bro.
mouse actually.
Okay, so
Can you
now
see my
you
mouse?
got this is
Okay.
just.
Yeah.
Did you zoom in on that distant target at all in this video?
It's already zoomed in. The Theodolite's
That's
got
as
like
far
a
as you can zoom
24
around it?
times zoom. Yeah. Anyway, what I want to say was,
And
so
did you show a comparison though? I mean, did you zoom back out, zoom back in? Did you show any of that?
it's a fixed focal length, right, on the Theodolite. Now, the measurement that I
Trust
got,
the science.
20,
Trust the science.
20, or trust the fucking measuring, the precision
Trust,
measuring instrument.
What's that
trust the
distance?
pseudoscience.
What's that distance we're looking at too?
Trust the
Oh, I don't know what the
pseudoscience.
boat was. Yeah,
Trust
Wait,
Wait,
the
wait,
brain
wait.
button.
What's that
Yeah.
distance we're looking at, Rohit?
I'd have to look it up. Yeah, I'd have to look.
You'll
it up.
have to look it up.
Yes.
Don't you think that
Like
that
I
would be
said,
kind of fucking important?
Like I've said, I've made 1,000 of these measurements. So
Well,
I've just picked one at random.
And you don't
Now,
know
the
the
point-
measurements of it. Okay, cool.
The point of this observation, right? I measured 21 arc minutes below horizontal. On the reticle, the crosshairs, 21 arc minutes is about 3/4 of the way up between the crosshairs and this stadium arc. So this is horizontal where my mouse is there, approximately there. That's where horizontal is. So if you think I'm off by a fucking pixel down here, I don't give a shit. This is how big you've got to deal with below horizontal.
Well,
Right.
let me tell you something. This is what the problem is. First off, you need to zoom in to see the actual horizon because you're only seeing the apparent horizon from your distance that you're viewing it from.
You're grasping
Okay?
at straws big time.
No,
And
I'm
it's-
not
it's
grasping at
pathetic.
straws. Secondly, we would have to know what the target distance is from the point that we're looking at right here. That would also be able to give us an indication as to what expected curvature we should actually be seeing, correct?
No, I
We
just
can
need the
actually
height.
even compensate for eye level appearance to that, okay?
I just need
So-
the height to know the distance. Sorry, I need the height to know the angle to the horizon. That's all I need.
Just ask the government; they'll tell you.
The height.
So what I'm saying is
Say
that
that again.
nice, you put some crosshairs out on what you thought was the apparent horizon, but I see a heavy
it not?
degree. I see a heavy degree of the apparent horizon. You do know the difference between a physical and an apparent horizon, right, Rufif? Do you know the difference between those two things?
Depends whether you're an
No,
Oak
there's
Tree
no
Cult member.
depending on it at all. There's an actual fucking horizon and there's an apparent horizon because of the optics, okay? There are two different horizons involved here. So you're looking at an apparent horizon with severe atmospheric opacity involved here. So if you were to zoom in on the target, you would see that the horizon does indeed go well beyond the target as the target will pass below the crosshairs. Trust me, I've done it too. So showing me a still picture or a 32-second video of you just looking at through a telescope with an angle measurement on there of 20 arc minutes down. How far is that? Is that a mile? Is that 5 miles? Is that
I'll
10
work it out for
miles?
you.
Is that 20 miles?
In fact, I will
This is
tell
all
you what my
information
observer
that
height is.
This is all, and then you tell me that the lens doesn't zoom in. What the fuck good telescope is that?
You know what we can do is actually work out my observer height just by the angle that I measured. Do you want to do that?
Listen, I've done the curve calculators. I've done this in the desert. I've done this at the ocean. I've done it at the Great Lakes. Okay.
All right. Who wants to work out the observer height?
I've been on top of mountains. I've been in excess of 10,000 feet in the Sierra Mountains. And I've looked out across the horizon, deriving its word from horizontal. And I look across the horizon and I see absolutely no evidence of curvature. I've flown around the world. I've been all to Europe. I've been here all over the
He's going to give you the height of the observation.
And even at those heights, the horizon still remains approximately at eye level, not down below me. When I look
Yes,
out
it
the
is below
window
you.
of an aircraft at 40,000 feet or 30,000 feet, I don't have to look down to see the horizon. I can
Yes,
look
you do.
straight out ahead and see
No, you
the
don't.
fucking horizon. Okay, so
where are we?
there's no curvature given the size of a globe that we're supposed to be on.
Now, who
So
wants,
you
who
would
wants to
either
have some
have to
fun?
concede that the globe you believe is much, much larger than we're told, or that there's no globe at all. There's no other way around it.
Who wants to have some fun and work out the observer height just by the angle that I measured?
Ruhif, you've been
90 point.
Ruhif.
What was it? 90.2.
90
Y'all go
90
ahead and play with
degrees,
that. I'm gonna
21
By the way,
minutes and
fucking
40
bullshit.
seconds.
Unknown, welcome to the show. Appreciate your
I'm gonna-
patience. Appreciate
I'm
you
gonna
coming on.
calculate.
Yep.
So
I'm
each arc
calculate how
minute.
long it takes a camel to pinch a shit off.
You said 21 minutes.
Yeah, 21
21
minutes,
arc
40
minutes?
seconds, which is 21 by 60 plus 40 by 3600, 0.361 degrees. Let me 149.
Shout out to Mischief Brew
148.
for the $5 tip over on Rokfin. Huge. If anybody else would be so kind as to support the show, you can do so on Rokfin or at buymeacoffee.com/troubling-tribune. Shameless plug out of the way. Feel free to continue.
You're,
All right.
you're on Rock.
So
Fans
I've-
too. I didn't know, man. I didn't know you
I've
was on
plugged
that.
it into Metabunk. I've just plugged in an observer height into Metabunk until I got an angle down to the horizon of about 0.361. And the observer height that it gave me was 148 meters. All right, so let's bring up another photo of where I actually was. Give me a second. Not that one. Not that one. Not that one. Where are we? Where's the fucking photo? There we go. Let's share that one. Is that sharing on the screen? What's sharing? Not that one. Hang on. Share. Stop sharing. Boom. Window. That one. All right. That's where I was. Taking those observations on that day. And let me grab a, where are we? It's called a place called Beacon Hill in Sydney. Beacon Hill.
How's that Southern Cross down there, man?
It's lovely. All right, I'll take a screenshot. All right, so when I put my cursor over where I was, it's between 149 and 150 meters at the lookout. There you go. Globe prediction matched. Everyone's shocked into silence. It's almost like the predictions of a globe are consistent with reality.
To be quite honest,
No,
Ruhif,
actually, I wasn't even listening to your fucking nonsense.
Of course you
I was
weren't.
waiting for you to be
That's
over.
why you're a flat earther,
That's
David. That's
happening.
why
No,
you're a
it's
flat
not.
earther.
Actually, it's because I've actually heard all that stupid shit. Why the fuck are you up on a hill? Go down to the goddamn lake shore. Go down to the seashore.
Okay.
Take some real fucking measurements.
Yep,
you know,
that's fine
you're
on that
not
one.
doing that. You're not. Why
That's
are
fine
you
on
up
that
on
one.
a fucking hill? What the fuck is that?
Oops.
Go down on the
Let's-
shore and take some fucking
Why was
level
Daytona in an
pictures
airplane
of
though?
shit. That, you know, go out there and then zoom in. And this time, when you do your little thing, zoom in on the fucking distant object so that you can see the horizon beyond it. You know, you have the fucking light refracts the curve of the earth up so it looks flat, but it really isn't. You know, that ridiculous shit.
There we go. There we go. Here's another one a bit closer to the surface.
So what kind of a zoom do we have on that? What? Because I
24.
know the Earth to be flat, so I want to know how far we're looking out there because I'm giving you an extreme hypothetical here. If we were looking out, say, 200 miles beyond, right? I'm just giving you a hypothetical. If we were looking out, then the slightest, you can move it down to 90 degrees and it might still well appear to have the crosshairs on the horizon.
No.
Because the farther away, just the slightest adjustment's going to make.
So this one here.
Does that make sense? Do you know what I'm saying?
Yeah,
Like
you're
if
sort
you're
of-
measuring 10 feet in front of you, the slightest adjustment on your theodolite is going to look like a huge difference. But could
Right.
you not
So
have you put it to 90 exactly and shown us what their crosshairs are?
Yeah, I'll tell you what the crosshairs look like. All right. So this angle measurement was 90 degrees and it was 11.5 minutes below horizontal, right? If you look at the crosshairs, oops, not that one.
Yeah, but you have examples where you set it to exactly 90
Okay.
and then shows the crosshairs.
Well,
No, this is pointing at the horizon. This is pointing at
I
the horizon.
know,
And
but
it's,
I'm
that's
asking
below
you,
the
do you have
horizon.
an example where you set it to show exactly 90 degrees and show us what the crosshairs look like?
no. What I'm showing you here, the distance, can you see my
didn't answer
mouse?
Right,
Yeah, see my mouse on these lines, right?
right.
The distance between that line and that line is 0.29 degrees. 0.29. Right, so about a third of a degree. Okay, so when I measure, what was it, 11 minutes? That's about a fifth or a sixth, right? Between a fifth and a sixth of a degree. So it's approximately half of this, right? This is that's where horizontal is, way up here, right? Way up here. That's where horizontal is.
That's
I'm
where
still asking you,
horizontal's in the middle of the crosshairs. Down
No,
right here in
that's
the
not
middle of the
horizontal.
fucking picture is where the middle of the crosshairs are at. Have you ever done any
No.
long range shooting, Ruhip?
No, the crosshairs.
Have you ever
are
done
not
any
horizontal.
long range shooting?
With a
Because
gun?
I'm looking at your crosshairs right here, and I actually can see that your crosshair is a shit hair just below the actual horizon, which would account for your measurement on your degrees.
No.
Now, don't disagree because anybody can look here and fucking see it.
I want to ask
The
you.
distance-
No,
but
I'm
I
going to
wanna-
tell
certainly
you
looks
another
like it's
thing
right
too.
on the line there. So
Ruhip,
yeah, I have to agree
Ruhip, I
with
want
David.
to tell you another thing. I'm a long range shooter and have
Okay.
been for many, many years. Okay. Never once have I ever had to use the goddamn Coriolis effect. I can tell you that. All right. Now I can tell you right now that much difference over that little tiny, almost imperceptible difference that you have where your crosshair is actually below that fucking horizon line just by a hair, that can mean the difference in a long distance between hitting the bullseye and being a foot off or more,
Okay.
depending on the
Okay.
distance. Okay.
Right,
All
but
I have to do, I've shot at distances where I could have a fly land on my fucking scope and screw me up by 4 feet.
Okay.
That's how
but this-
sensitive that those distances are. Now,
Right.
I can see clearly that your crosshair on the right, which you claim is to the horizon, is actually just about the same thickness as the line below the actual horizon. That would account for your downward angle. The next
No.
thing you need to do is you need to get a distance out there because you're only going to see an apparent horizon with the naked eye at 3 miles. So what we're seeing again is an apparent horizon due to optics. We're not seeing an actual horizon.
All right. You're claiming that my measurement here is so sensitive that could be horizontal.
I'm saying that
Right.
that extra downward, I can see it in the crosshairs, dude.
Okay. Whether that's there or not doesn't matter. The scale, right? The scale of this thing
Yeah.
between the top stadium arc and the
Mhm.
bottom stadium arc is 10 milliradians.
Right.
That's
which
what
means
those
the
stadium
middle's
arcs
5.
mean.
Means the middle's at 5.
No, the middle's at 0. The middle's
Well,
at
okay,
0.
we go 10 either way. But what I'm saying
No,
is
no,
that's
5
the
either
bit-
way.
The center's the center. So
Yeah, the center is
who
what I'm
cares
pointing
where
at.
that line's at and that line's at. The center's the center. It doesn't matter. The only time you're ever going to have to use any of that
Let's
shit
draw
is
it.
if there
Hold
is
on.
a difference. It's like the
Let's
mill
draw it.
dots on my
But-
scope.
Are you
It's
not
like
telling us
dots on
too
your
that
scope, man.
refraction will change where we see the horizon? So what in the world are you lining up with? How do you imagine
Hang on.
where your horizon is? How do you figure that out? If you're telling us it can magically appear wherever, then
Well, apparent
then
horizon.
why are you going with the parent right there? Yeah, if you're telling us that what we always see as apparent isn't the actual horizon, so how would that device tell us anything? And also, I would still like to see an example where you line it up, set it to 90 degrees, and then show us what the crosshairs show.
Right. Hang on, I missed a bit of that. I'm just drawing the crosshairs in the middle and then the stadium arcs at the top and the bottom. And that distance from the top to the bottom is 0.57 degrees. Okay, that's 10 milliradians. Okay, if I then draw this is 0.28 degrees. Okay, half of that. The angle that I measured was 11 arc minutes. 11 arc minutes and 40 seconds. Which is 11 divided by 60 plus 40 divided by 3600. That's 0.19. So 11 arc minutes, 40 seconds equals 0.19 degrees. Okay? Oops. So the angle that I measured with the theodolite is 0.19 degrees. If you scale that against this 0.28 degrees, then your horizon line, your horizontal is going to be about here, right? And you're talking about a pixel here, right? Do you see how far off you are by 1 pixel?
Listen,
right?
you're measuring once again. Let me explain this to you again. Maybe you don't get this. You have a bubble of vision that surrounds you that is limited. On the horizontal scale, it is limited by the atmospheric opacity and almost goes into a conical shape as you look up because of the less denser area. So if you can imagine, about 2 to 3 miles is the farthest you can actually see before things start to go into the horizon. You can see a little further up because of and it all depends on the atmospheric opacity. When you magnify, all you're doing is strengthening your eyes. Now, what you've placed the crosshairs on at this far back distance is what's known as the apparent or visual horizon. It is not a physical horizon. So if you to do this honestly, what you want to do, listen to me.
Don't start.
You set this thing up so that it's dead nuts at 90 degrees. And what's cool is it may appear to be above what the apparent horizon is at that zoom level. But you will find rather quickly that as you zoom in, your crosshairs are going to be on an actual visual horizon through the atmospheric opacity and not from a visual perspective that was caused by the atmospheric opacity.
That's why I asked to see one set at 90 and then show us where it is.
Right.
Well, where the diagram on screen is telling you when.
You're showing me a diagram. I'm telling you, I want to see physical visual of it set at 90. Yeah. And then I don't know if they would have the zoom capabilities to do it compared to my P900 or P1000 or whatever, and then show where those crosshairs meet up. But you know what? None of that would make a difference.
I'll show you this. Hold on.
Yeah, I mean, the absurdity that we're even at this state of this absurd argument when it's been proven over and over that there's no sign of curvature, that we're at this level of talking about these little numbers.
I know.
I mean, it's laughable. So I want to ask. Look, this isn't a very good curve, but pretend like this part, my hand is a globe, right?
Hang on, I'm just getting what you asked for. 1 second. 1 second. Hang on.
And I don't pretend to understand all the math and everything behind refraction.
Maybe you should. Maybe you should, and then you will not be a flat earther.
I don't need to.
Why? There's no.
I don't need to.
That's not why you're seeing shit. It's not refraction. It's because it's not
exactly.
Curve.
But I want to know this. Look, okay, my hand. Forget this is like 1/4 of a globe right here, right? And we're up here. And if we're seeing down here, are you telling me that? Can you?
I was getting what you were saying unknown.
I can see.
Yeah,
I got
and
you.
I would change my name on there. I don't know how to. I never use
I
this stuff.
either.
I don't know what to. I don't
Can
know
you see
how
what
to get
I've posted
anything
now,
besides you written there.
Can you see
So
what
if
I
you're
posted?
1/4 of a globe and you're like this,
So I want to know this. So if we're right here, this is 1/4 of a globe, and we're at the top, right? And then here's around. All right. So from what the globers say is that if I'm seeing, say, however far, like say that we could see to this point, right? And I'm seeing it like here to here, right? And this looks flat to me, right? But you all the globers are telling me this is curved. So they're saying that refraction will pull this part up a little bit to look flat, this part a little bit higher, this part a little bit higher, this part, and it'll pull this part refraction up this much higher, just perfectly. Like the atmosphere must be different to where it's going to pull this part up this high, and it's going to pull this part up this high so that it all looks flat. Does that make sense?
No,
That's
I
absurd.
understand.
That's absurd.
ridiculous.
No, it's not.
It is absurd. Like,
No,
oh,
it's
it's
ridiculous,
the
man.
conditions at 1 mile past the alleged curvature are such that it's going to lift it up just enough to look flat, and it's going to work out perfectly to where the refraction all the way down to 50 miles. At 50 miles, it's going to work to where it's going to bring it up this much higher, and it's going to look straight the whole way. Why wouldn't it do like this? Why wouldn't it make it look like this? I mean, or like show another
we can talk
curve.
about that next stream.
I mean,
I've got to go in a couple minutes.
Personally,
It's really not. It's what's expected. Honestly, it's what's expected.
No.
Personally, I would like to. I'd actually like to see the observation done with an infrared camera. I think that'd be really cool.
Yeah, I'd love to as well. I love JTOL and stuff. So what I've got on screen is not through a theodolite, but through an auto level. So this literally just points horizontally, right? So you can see that it's got the same stadia marks that are 10 milliradians apart, and you can see where the horizon is way below eye level.
Can I ask you something, Robiff? Why do you film in such cloudy, dense conditions? Why don't you go to a more arid environment, like, you know, maybe when it's not so humid, so that you can actually see what we're doing here? Because there again, out to sea, atmospheric opacity again is fucking with the entire thing. Absolutely.
Okay. Whatever, dude. Anyway, that's an auto level. That's where horizontal is, and you can see how far below.
Are you about to run?
Yeah, I've got to go get my daughter.
That's the apparent horizon.
Are you running? Is this where they run? Is this the part where they run? Is this the part where they run away because they can't defend themselves?
Dude,
I would love to come back.
Defend the defenseless. This is
All right.
just pitiful.
I know.
So,
this is the part where
I'm gonna go ahead and pump the brakes on the ad homs just because people were calling for a little bit more moderation in the chat.
I will just add. I'll just insult you back, right? So let's not do that. Anyway, I've got to go. Trouble. I would love to do this again.
Run.
Send me a DM stuff when you do this again.
The same
Absolutely,
thing
Rudolph. I appreciate you coming on. Thanks for presenting.
No worries. See.
Oh shit.
Oh man, I went to grab my coffee cup, and a fucking refraction made me think its speaker over here was my coffee cup and shit. The light was bending around and stuff because of the heat from the coffee and swamp gas from Venus and shit.
I'm really in the other room, but I have a special video light on me, and it's making me look like I'm in here.
Yeah, isn't that cool how you do that?
It is cool.
I remember, man, when we were guarding the East-West German border, I used to face north so that if I could fire and see the guys over here to the east. See, real tricky because they didn't know I was actually shooting at them. I was refracting bullets around the earth.
So our friend Adam has about 10 minutes left. He said he wanted to kick it by about 1 o'clock. So there was one topic that I wanted to touch on with him, and that was going to be celestial navigation. So it is a shame that Ruhif did have to peace out because I definitely wanted him on for this conversation, and I'm sure he'll be back. But in the meantime, we can go ahead and touch on it. The flat Earth claim with it is really simple. It was done with Euclidean geometry. You're solving for the triangle. The Earth is the baseline. You're using the general position of a star, and you assume a spot on the Earth directly beneath that star. Of course, all of this is perpendicular to you, so it wouldn't make any sense. It wouldn't work if the Earth was a ball. The only rebuttal that I've heard is that that we're using a different tangent that, if you look at it, actually cuts through the bulge. So essentially, you're admitting that you have to measure it flat. But you said that you've dug into this, that it was a really good subject. Adam, I'd like you to have the floor for a moment and show us what you got.
The tangent, it doesn't go through the Earth. The tangent goes, all the measurements that are taken are from above the Earth's curvature. So in the video that you sent me from, first of all, hold on, let me start with this. You cannot get a position fix from Euclidean geometry. You cannot get a position fix from it. There is no source that you can cite. There is no evidence that you can bring up. You cannot get now I know you sent me a link earlier, and I feel like you didn't have enough time to look into it. So I'll give you the benefit of the doubt on that one. I feel like you didn't have enough time to look into it. feel like you Google searched and you sent me the first link that you found. The
What's
link that you sent
Adam?
me,
What's Euclidean geometry? Please, I have to.
Euclidean geometry
I gotta
is
understand definitions before I can continue to understand what you're saying.
so Euclidean geometry is geometry that's done on a flat piece of paper. So 2D geometry.
Okay.
So circle, triangles, it has nothing to do with third dimension. So I sent you back the link inside of your Gmail. I don't know if you read the article that you sent me, but it has to do with tests that were done with 4-year-old children, and they were supposed to find toys in the corners, and it had to do with navigating in a 2-dimension. It was really weird. It had nothing to do with celestial navigation. So we can Ruhif, I was trying to remember his name. Ruhif touched on a couple of things earlier. So with celestial navigation, you have a sextant. In the old days, they had they were called astrolabes, and then later on in the 15th century, sextants got really popular, and we would be able to take the sextant from a location wherever we were, whether it was sea or land, looking into the sea, but you need a horizon. And you take the sextant, you shoot it to a star or the sun, and you lower the star down to the horizon with your different levers, okay? And this gives you an angle. So from that angle, right, it's not a triangle. The observer height shoots out, okay? And then you have the actual thing that you're observing. And from that angle, you can find your zenith point. So you have to refer to books and almanacs. And so the zenith point is going to be the point that's directly under the star that you're looking at that's apparent to the Earth. So when you shoot a tangent line...
Adam, I'm sorry to cut you off. I just want to make sure you understand the word that you just used, the apparent position. The reason why they say that is because you're not actually seeing the area underneath the Earth, the area underneath the star, supposedly. It extends way past the actual visible horizon, because as we all know, you can't see forever. So
yeah, but light always moves parallel. The light that we perceive, the light that we perceive from the stars, from the sun, it always comes in parallel. So based on those parallel lines, we can fix a position. So if we shoot a sextant into the sky, we can see whatever angle we're looking at the star at or the planet at, right? That zenith point.
There was absolutely nowhere that I read that we had to calculate for the angle. I did read that we use the position that we assume is directly underneath the star, but nowhere in there is it saying that we have to angle it to get that. In fact, I mean, I'm curious to see you draw it out or something like that, because I've seen diagrams where they're doing it and it's flat triangles. So I'm really curious as to how you would solve for the triangle with the curved Earth between you and the observation.
The sextant gives you the angle of which you're shooting at apparent to the horizon.
Correct.
So, right. So it gives you an angle. So if we shoot a tangent line above the surface, it's not going through the surface. It's going above the surface, right? Whether it's curved or it's flat, it doesn't matter. It's going above the surface.
You realize we're not actually shooting a line where it's an imaginary line that we're assuming between us and the ground that's underneath the star that is supposedly way past the horizon. So I get you that we derive the angle using the sextant, right? That gives us the first angle. Then we assume a 90-degree angle at the point of the Earth and the star. Okay, that's the second angle. And then we solve from that to get the third angle. Okay, so we're actually assuming a 90-degree, like you said, parallel from the star to the ground. So, from the ground to the star. So from the star now, the star back to that angle up top. It's hard to word it right. You know what I'm talking about, though. That's pretty much the only one that you have to solve for, assuming that you only have 180 degrees.
And this is why I asked you about the R value. So when you're dealing with spherical geometry, right, you can shoot a tangent line and plug in an R value to the known radius, and we can account for, using trigonometry, we can account for the arc curve. Does that make sense?
No, because you literally just assumed that, and you assumed it to calculate for a curve. Like,
Well,
you haven't even attempted to do it for a flat surface, have you? And how do you derive an angle on a curve?
This is what I'm telling you. You cannot do a position fix on a flat surface.
So my claim is the
cannot
opposite
do-
of yours, is that
You cannot
can't do
take
a
a
position
compass.
fix.
Skylar, you cannot take a compass and do a position fix on a flat map. You
Demonstrate it.
cannot do it.
Because all the nautical
you
maps,
can.
all the nautical maps are flat.
Dude, that's what they've
And
done.
they're
now
all
for
based on
1,000 years.
listen, they're all based on a trigonometric formula that has to do with spheres.
They're actually
No.
not.
They're all
What they
based
are
on
is
spherical
they're.
geometry.
No, it's
I actually
not.
looked this
Oh,
up directly
Yes, it
after you
is.
sent
When
it
you
to
do
me.
a
Or
site
that word.
reduction, yes, it is. Listen, you can say whatever you want. You can dress this up however you
All
want
right,
to,
I'm going to show
David.
you then.
When
I
you do
have
a site
one.
reduction, it's all based on spherical geometry, and all of the spherical globe is reduced into a flat piece of paper. It's called the Haversine formula. And this is what all of the navigational charts are based off of. You cannot, and I repeat, you cannot make a position fix based on Euclidean geometry. You
Yes,
cannot
you
take a
can.
flat map and draw circles, and you cannot.
It's
Yeah.
amazing they were able to
Challenging.
navigate for so many,
Dude,
many
that's
hundreds
exactly
of thousands
Okay,
of
so-
years
what they did.
before the globe came about. I guess they were pretty dumb back then.
I think that we have a different
A
meaning for
sextant,
Euclidean
the sextant has
Again,
always worked.
geometry.
The
Because you-
first thing that we came out with, okay, the first piece of technology
joke.
that I know of is the armillary sphere, okay, and this is how they would measure the zodiacs. And then from the armillary sphere, they upped their technology to the astrolabe, and then from the astrolabe they upped it to a sextant, and they incorporated all of this geometry into the technology that we have today. So my question to you is, Skylar, I asked you, how accurate is celestial navigation in your opinion? And you replied to me that it is within 1 arc minute or 1 nautical mile. Right?
Yep.
So if celestial navigation is that accurate, how could Australia be that far off on the map? Like at the last time we talked on the podcast, you told me that we don't know where things are on this world. We don't really know where the continents are. If it's
The reason why we don't
accurate within
know-
a mile,
The reason
how
why
could
we
these
don't.
land masses be off by thousands of miles?
Okay, awesome. So now that I can address your points, and they seem good on face value, but you're failing to realize that we're relying on information that is hand-fed to us. We haven't done the measurements ourselves, and I believe I specifically stated that in the fact that we don't know the true position of things. I'm not saying that other people don't. I'm not saying that there isn't a class of people that can figure it out. I'm saying that we do not. We have not gone to the ground. We have not done the measurements. However, if you bring up nautical maps, you say that it's based off of this trigonometrical formula. That's actually, I mean, according to the first search that I found on Google, it's not true. The way that they base their nautical maps is actually based off of, for one, radar. They actually send a radar signal out and get a topographical, what's the word I'm looking for? A model, basically, of the layout, and then they map that down. That's one way they do it. Another way they do it is by using low-flying planes, and they take pictures of local areas, and then they stitch out bigger maps. So this is literally how nautical maps are made. And then as far as the geometry to solve it, what I meant by Euclidean isn't two-dimensional. That's not what I meant at all. What it assumes is that we're actually a flat, stationary Earth, and that the celestial sphere is what's spherical, not the actual Earth itself. So what you do to actually solve for the triangle, and why I say it's impossible to do on a globe Earth, is because the star that you are bringing down to the horizon to get its angle, that place above the Earth is way, way past the horizon. It's not a couple miles away from you that you're doing this measurement to. You're getting a flat circle of elevation, a flat circle, no elevation, from a fixed position, and you're using that from a star that's presumably, in some cases, 50 or 60, 70 miles away even, that you can do this. And again, you're assuming a 90-degree angle on the ground to the star, and then all you have to do is solve for that other angle. When you invoke a curved Earth between you and the star, there is no choice unless that line cuts through the bulge. That line cannot be flat. You're doing a distance that is way too far. And I know you can say, well, we're doing a shot above the horizon. The problem is that we can do it from an elevation height of like, let's say 20 feet. We can do it from the deck of a boat low on the horizon, and we're shooting out to a star that can still be pretty low on the horizon, but can give us a measurement possibly even hundreds of miles out. It's just solving for a flat triangle. As soon as you curve the baseline, which is the Earth, which is the measurement that we're trying to get, the distance between you and an object underneath a star, as soon as you curve that line, you can no longer derive an angle. If you don't believe me, go ahead and try.
You can, because you can convert the degrees into radians. What are you talking about? You can.
Go ahead and try.
Listen, I'm telling you that you don't have to do any conversions. All you have to do is shoot an angle and cross-reference them with your almanacs, and you can go onto a globe that's spinning in your house, and you can take your compass and you can lay out you can lay your compass on the prime meridian, and you can draw out all of your fixed points, and you don't have to do any reductions. You don't have to do any of it. It will work perfectly on a globe model.
I don't know what you mean by like reductions. It works perfectly with the flat Earth model.
It does not. You cannot do that. Listen, I'm telling you, you cannot do that.
Demonstrate it.
Well, how'd they get around all that here? How'd they get around for centuries?
Listen, you cannot do it without the Haversine formula.
The Phoenicians did it.
Without
the Phoenicians.
Adam, how did they do it for centuries without taking into compensation of a globe?
I just told you, David.
Now we have to compensate for a globe because now we discovered it. I just told
you.
What year did the Haversine formula come out? That's the best question that we can ask, Adam, because I really need you to see this.
We can Google that. Google it. Google what year it came out.
Well, I don't
know.
David,
the lights in your room moved you to another room, just like it did to me.
Because before I was
saying your lights moved you into another room, like happened to me.
It did.
See that?
It did. I'm in another part of the spaceship. I'm in a spaceship. Ooh.
I love
David's on Saturn right now.
Refraction and gravity, how magical and selective they are.
Those are my buzzwords. You know, every time some glober says refraction, gravity, or parallax, I have
math.
Or math.
You say that word.
So here's a problem. So the Haversine formula come out in 1805. Now we have two notable explorers that were exploring using celestial navigation, using sextants. I mean, sextants were invented in the 1500s. So we were using sextants before we even used the Haversine formula, and we were navigating on a flat Earth. And also the first people to use celestial navigation were supposedly the Phoenicians. And if you believe in mainstream history,
this is when it was
that's like
published,
2000. That's like 2000.
Hold on, no.
Old.
It was published in 1805. Read the whole Wikipedia. Read the whole Wikipedia post. That was the year that it was published. It doesn't mean that the formula didn't exist before then.
That's why I asked you to. That's why I asked you to Google it and just tell us what it was. Because if you're just gonna say I'm wrong, I mean, we could just save some hassle. I'm not trying to BS you. So what was the date?
Law of Haversines related to sines of angles of spherical triangles. The first table of Haversines in English was published by James Andrew in 1805, but Florian Cajori credits an earlier use by Jose de Mendoza in 1801. The term Haversine was coined in 1835 by James Inman. This is just the year that it was published.
So the earliest mention of it was 1801. Can we agree on that?
Of the name, 1835 is when Haversine was named.
Sure. When was the formula? The actual formula. It said that you took it from somebody in 1801. I'm taking the earliest. If we take the earliest mention of anything even resembling the Haversine formula, it still puts it 100 years.
That was when it was published. That was when it was published, Skylar.
So are you claiming that this was a formula that they were using for hundreds of years prior?
Why not? People built the pyramids 4,500 years ago.
Present evidence for the claim.
How do you know that?
Present evidence for the claim, my friend.
You assume
I'm just telling you that the early humans have been doing math since before it was published.
Oh, there's math again. I like that word.
There it is.
Guys,
Adam, how do you know this thing about the pyramids? I'm curious to know about that because I've been wondering.
I mean,
the Earth is billions of years old.
I mean, you understand that there's literature that dates back to that time, right?
Do you know how they date literature?
To what time? The pyramids?
Yeah,
Really?
the Hebrews, the Chinese, all of these people had very,
You read
very
all
in-depth
that?
and detailed
read that?
literature.
Yeah.
What? Yes.
You did. So you read Chinese and all that shit, right?
Yeah, they had
Tell me-
detailed literature,
I mean,
and all those
no, no, no,
civilizations
no, no,
knew we
but-
had
but-
a
but you're
flat Earth
assuming
to
you're
confirm it
One
with.
at a time.
And this is what happens a lot of times is just because if you don't like to learn, don't listen to other people. Listen
Well,
to
it ain't
yourself.
about learning. If I learn something,
I mean,
want
it
to
is
know
about
that
learning
it's
because
true,
if someone
not just-
passes on information to you, if someone passes on
No,
Have
knowledge
you read-
to you,
not learning?
Do you
That's
realize
not
that
learning? Telling
that's the
telling
stupidest thing
someone
I've ever heard.
something. Hold on. Telling someone something is not learning. Listening to what someone says is not learning. Taking in information and running it through the filter of intelligence and deciding whether it has validity is learning. Okay, because I could tell you all kinds of
Who
cool
decides
shit.
what's
I live
intelligent and
in
what's not,
Narnia
though?
and I eat unicorn steaks once a week. Okay, I could tell you that. Look what you just learned about me, that I live in Narnia and I eat unicorn steaks. Did
That's
you
not what I
learn
learned about
something,
you
or
by
did
you
I give
making that
bullshit?
statement, though.
Well, do you see what happened? I just told you something. You didn't learn it. Now, if I
But
make myself an authoritative figure and tell it to you, then it becomes true, right? I put some letters behind my name, like PhD or BSL or some other.
This is a preposterous argument. I don't
You're
want to have
not
it.
applying. You're
That's
not
a
applying
preposterous
So-
logic,
argument.
Adam.
It's
You're
logic.
not applying
It's
logic
logic,
to anything. You're not applying. You're not applying any sort of logic to any
Austin,
of
let's
your.
agree that you don't understand what's going on here.
Yeah, I don't care what you think I do understand or overstand or understand. I don't care because I understand you to a completely different degree than you think I do. So there's nothing that you can learn about me that I don't already know about you.
Well,
That's
I mean,
deep.
cool.
what I'm trying to give you, Adam, is actually I'm not giving you shit. What I'm trying to give you is this.
I am.
We make these assumptions based on what people have told us. You know, we say, oh, well, like you stated as a fact that, well, the pyramids were built by people such and such amount of years ago. You don't really know that. We know that that was told to us. Okay. But there's evidence that is contrary to that. And we must consider that as
I mean,
well.
again, there's literature
Because
that goes back
what we
to
have
those.
to look at is we have been given information by known fucking liars.
And Skylar, thanks for having me on. I got a notice about 10 minutes ago. I'm not used to this, that I guess it's about to kick me off.
Yeah, it's about to
So-
kick everybody, but
Thank
I'm about
you.
to launch it again. So everybody feel free to hop back on in. I'll probably have it go another 30 minutes to an hour or so, and then I'll call it. I did want to do a
Yeah,
Q&A.
I'll go till 1:30, man. I know I said I was going to get off at 1. I'll go till 1:30. I like where this is going.
Sick.
Yeah,
sick.
that's cool, Adam.
I wanna
you
believe-
gotta question everything, man. Question every fucking thing.
I'm
just-
trying to believe in the globe.
What do you think I do though, Dave? When and this again, I put the work in, man. No one on this stream could ever tell me that I don't put the work in.
Oh, I'm
I
not
go
accusing
out-
you. No, I'm not accusing you of that, bro.
I
What
put
I'm
the
getting
work
at
in.
is,
So
though,
at the end of the day,
it's
if
easy.
if the work that I'm putting in, right, doesn't align with your beliefs, I don't care.
Well, what I'm
And
getting
I
at,
don't
no, Adam, what I'm showing is this, is that there are even what we just take for granted that we're given shit like that, like the pyramids, this, that, or the other. And we just take it as because it's been pushed into us and we take it as like, oh, we just spout it. We don't really know. And what I'm saying is we have to consider everything because we've been given shit by a bunch of fucking liars. So much is untrue. And we find that out. And so now that calls everything into question. You see, we know they have an agenda. They don't want us to have the real information.
So, but when somebody tells the truth, though,
Call is about to
you can't
end.
just call them
Hold
a
your
liar.
point.
The-
Come out, everybody, come
truth.
back on in. We're all about to get booted. So I appreciate everybody. Stay right there. The show is not over. We're gonna keep this thing going. It's gonna kick us in like 20 seconds. We'll get right back into the point of celestial navigation. I'll see you in a second. All right, audience, we're obviously still here. So let's go ahead and get this running once again for part 3, the finale of the exciting series. We're going to be doing a Q&A here in just a minute. Get through this celestial navigation. I don't think Adam is really getting it on that. We absolutely have to use a flat triangle in order to get this measurement. I don't think he's ever tried to do this with a curved triangle. But hey, you hear it in a YouTube video once and you get proficient, then why not try to spout it, right? No, I'm just kidding. We love everybody. We try to give them a chance. So, again, I appreciate everybody tuning in. If you like what you are seeing, consider supporting the show. All of your donations are going towards better equipment. That way we can get even better shows going here, higher quality, more guests, more slides, all the stuff that keeps you guys wanting to watch. So we definitely appreciate you tuning in. Go to buymeacoffee.com. That way you can have your super chat read live. Absolutely awesome. Okay, let's post the new link. There it is in the YouTube. Boom. All right. Let's go to the chat for the Rokfin. Paste. Chat. Boom. There you are. I expect to see you back in. Welcome back, David.
Hey, we made it.
Heck yeah. Adam, welcome back, my friend. Everybody's coming back in little by little.
I still haven't figured out how to change my name on this thing yet.
Yeah, I don't know how to do any of it. It just says you. So, but everybody knows that me as Troubling Tribune, so it's all good.
So, David, like we were talking about earlier, man. So, if someone gives me a bit of information, right, and I can go out and I can test it and I can see that it's true, is it true or is it false?
So, give me that one more time. I'm sorry, my audio was cutting out for a second. Go ahead.
If someone gives me a bit of information, right, and I can go out and test it myself and see that it's true, does that make it true or does that make it false?
Well, that would absolutely make it true.
Okay, so this is what I'm talking about with the topic of celestial navigation. You can go online, right, and you can order all these books on celestial navigation, right? You can order the books that the U.S. Air Force uses, the Navy. You can order the American Practical Navigator. You can order books by Harold Jacoby. You can order these books, and you can apply what they're telling you about the globe. Right? They're saying, okay, the Earth is a sphere, and this is how we do position fixes. And you can go out and you can get your exact position fix. Okay. You can go out and you can get your exact position fix based on this math and based on this knowledge that they're giving you, right? But you go out and try and do this on a flat map and you can't do it.
Have you tried to do it, Adam?
Who, me?
Yeah.
Have I tried to do it?
Yeah.
Yeah.
I say I got about maybe one more hour before I got about maybe one more hour of studying before I get a sextant.
Gotcha. Excuse me.
I have a sextant over here on the shelf back here. I also have an astrolabe, and I happen to know that not only will those two objects not work on a ball, neither will a compass.
They absolutely will work on a ball.
No, sorry. I'm sorry.
They will work on a ball. How does an astrolabe work?
It works off of the fact that the sky above us.
It's actually considered.
Do you know how to use an astrolabe?
It's assumed to be a celestial shelf, Adam.
I mean, even now we say that the sun sets.
It's called a celestial shelf.
Well, that's because of Set. Okay, when the sun sets, that's when Set, the god of the night, comes out and forever battles with Ra.
Nice. I didn't know. That's awesome that you know the Egyptian mythos. They're battling Apep to actually. He's not battling Ra. He's battling Apep to protect Ra because Ra's his brother. So just remember, in the Egypt mythos, darkness and light are brothers.
Yeah.
I have a machine that makes refraction.
Oh no. There you go.
Yeah.
Absolutely.
I wonder if you got the joke, Adam. It's because we can see too far.
Yep.
But essentially, I just to kind of nail back the point to celestial navigation before we lose it, it was, I mean, I gave a pretty clear description of how you can derive it, of how you can use the angles. It's not complicated at all. You just have to know how to solve for a triangle. So once you have the angles, you can solve for the distances, but not only between you and the star, but you and the point beneath the star. I mean, you can get really accurate results. That's why I asked if you had actually attempted to do it, because that was actually how it was done before they started assuming the sphere Earth. That we were navigating all the way using the stars all the way back in the Phoenicians' time, which is supposedly like 2000, 3000 BC. It's like ancient. This is so. I agree with you that they were using math before, before the Haversine formula was actually coined, but that doesn't mean that they were using spherical geometry. So, and when you go into the
Well,
calculations
Trouble,
for
I got something on that too. Trouble is that we use these demarcation lines of the tropics and the equator, right? We call the Tropic of Cancer in the north and the Tropic of Capricorn in the south. Well, the sun hasn't been in those positions at the equinox for 5,000 years. Actually, by definition, they're actually right now the Tropic of Gemini and Sagittarius, because we've already passed through 2 ages since those were calculated out. So that'll give you an idea how long they've been using the stars and these things for navigation.
now, Adam would
5,000
argue.
years.
Adam would argue that means that it was calculated to be a sphere for all that time, and that actually is what mainstream is trying to do. But this is easily debunked when you just actually look into what the cultures actually believed for the cosmological layout. It's very obvious that they all have flat Earth cosmologies.
Look at what's those things in those cathedrals all through Europe.
Let's assume, okay, Scholar, let's assume that we live on I'm going to assume that we live on a flat plane right now, okay?
Okay.
And let's say that video that you sent me from
yeah, I probably sent you the wrong source. I'm sorry about that. I'll have to look at it and be like, what the heck?
No. I'm talking about the video that you sent me on CellNav.
Okay.
And he's drawing the right triangles, right? Number one, did you read the description on the video?
I have before, but I don't remember what it is right offhand. I wasn't going for someone who was specifically a flat earther, though. It's not a prerequisite for what I was trying to show.
Okay, so number one, he's not a flat earther.
I know.
Number two, let's assume that we are drawing a 90-degree angle, right? It's a 90-degree triangle that he's drawing, okay? At those degrees, let's say that we make a sun sighting, okay? And we have a 90-degree angle and we shoot I don't know, a 22-degree angle at the sun, right?
Okay.
That means that we would have a distance and we would have an angle, which means that we could figure out how far the sun is away from us.
Right.
No.
You can get a general. You can get an idea of where the apparent sun
You
is.
can get a location of the sun. You can't.
No, you can get a distance from observer. You can get a distance from observers. A squared plus B squared equals C squared. It will work 100% of the time, David.
All right. So you show me that and get me 93 million miles.
No, that's not the point.
No. That's not what I'm saying. That's not what I'm saying. What I'm saying is, no matter what I said, I'm assuming that we live on a flat plane.
Okay.
That means that we will be able to know how high the sun is. Now, Skylar, you've told me that we don't know how high the sun is.
Right, because it's apparent.
Oh, okay. So it's apparent.
Right, and it's also
this isn't making sense again, because if you can shoot a degree at the sun and you have a 90-degree angle, okay, we should be able to find where that 22.5-degree angle intersects with that 90.
Okay, I got let's look at. I'm going to touch a little bit on what Troubling was saying. The apparent sun. Okay, you and I could be standing half a mile apart on the same seashore, watching the sunrise, and from your perspective, the sun is going to come up and make a line of light directly to your feet. But guess what? It's going to do the same thing to me. It's going to do the same thing to me. So how can it be doing the same thing in 2 locations at one time?
That has nothing to do
with the apparent sun that you're seeing.
That has nothing to do with what we're talking about, though.
It has everything.
A lot to do with
it.
It.
Everything to do.
It has nothing to do with what we're talking about.
Adam,
We're talking about We're talking about a triangle that has 180 degrees in it. Okay? If I have a 90-degree angle, a zenith point, going straight up, and I have a 22.5-degree angle going straight out, that 90-degree angle will intersect, which means that we can find what the other angle is going to be, which means that we know the distance, we know the height, and now we can figure for the hypotenuse.
Do you know what happens
What?
when
You're
you
not-
triangulate the sun?
What?
Do you know
Not
the
even
like when you
close.
use that method that you're describing? Do you know what the value comes out to how far the sun is?
What I'm telling you is if we assume that we're on a flat plane, and this truly is a 90-degree angle, right? And there is no trigonometry involved. We're just 180 degrees in a triangle. We can
Adam, I
figure
must
out
have
the
missed this.
distance.
I'm sorry, real quick. I must have missed this. Are you referring to like crepuscular rays?
He's not even using
No.
distance.
He's
using
referring-
angles.
he's
He's,
referring-
using
but
angles. He's
what's giving
trying
you
to
the
he's
angle?
trying to use angles to make out a distance. I don't understand.
Okay,
Yeah,
so
I'm
I'll explain
confused
it.
as to what.
Let me explain it to Steelman his position because Adam so far is on the money. I mean, I just want to be honest, here. What ends up happening is you can actually derive distances when you solve for the triangle if you assume a flat Earth. This is exactly what I was saying with how celestial navigation works because you have the celestial shelf above us, but that's the corner of the triangle. That's not our flat baseline. So what we end up doing is we have a flat baseline between us and the point beneath a celestial object. In this scenario, he's using the sun. And what you do is you assume a 90-degree angle from the ground up to the star. That's the second angle. The first angle is derived from the sextant. The second angle is just assumed to be 90 degrees. And the third angle is whatever's left over because we know that there can only be 180 degrees in any triangle. So once you have that, you can use sine cosine to figure out the distances between you and the celestial object, assuming that you don't have any refraction or anything like that. And you can also do the same thing with stars. Now with the sun, it's actually a lot more local.
Shoot your fable.
Now, using this, you can actually kind of prove out that the sun at least appears to be a lot closer than the stars do, because what ends up happening is when you solve for the GP using stars, that's where you're able to get positions and locations well beyond the horizon. With the sun, because it is relatively local in comparison, you end up getting very local distances when solving for the sun, so you don't even need to calculate for curvature anyway. What I'm more concerned with is when we're using the GP of a star, because we know the stars extend way past out what the actual horizon that we would see is. So we actually do have to straighten out this curve in order to get that 90-degree angle. Because if we just solve it as is, then that the surface of the Earth is going to be curved between us and the object, which creates a curved line. And when you try to solve for the angle with a sextant, using the curved line, because the line, every point on the line is different, every single point on the line will have a different angle. And so when you try to put it in a computer program or where you try to actually solve for this, it actually tells you it's unsolvable. You have to have straight lines for the triangle. And that's why when you actually look at the real globe math for when they actually are using celestial navigation, they flip the triangle upside down and they do it a different way. They assume a flat sky and then a curved Earth, and then they build the triangle reverse. So that's the actual answer, at least the one that I've seen that made a little bit of sense. But in any case,
I have not seen that, and this is why I asked you how you would plug an R value in, because when you plug an R value in, again, you can do an arc formula, and you can figure out and you can convert your degrees to radians. So there's 360 degrees in a circle, right? And you can convert the distance into radians. So it's not just it. So when you throw your line of your observation site, right? You're throwing a right angle at a zenith point, but it's not a triangle, and it's bisected by the sight line of the celestial body. So and then it's like it's dividing the right angle into an altitude and a co-altitude, and it's all done above the Earth's curve. A triangle isn't used when you're getting the distance from a geographic position to the zenith point of the celestial body. The 90 is from a tangent.
so the tangent is just a line, right? A tangent is a line. That's the definition. It's a line that doesn't extend forever. It's a piece of a line. So a triangle has 3 tangents. All right, there's a tangent between you and the celestial body.
No,
There's
the tangent extends. It's not a line segment. A line segment is intersected. It has a stopping point. It's just a line. You're just shooting a straight line out.
What's the difference
to the
between
horizon?
a
Tangent to the horizon.
So you're basically all you're doing is you're just stopping at the horizon and cutting the triangle, but that actually isn't the way that it works. I'm saying that you can actually do it while going past that horizon by using the general position of a star and calculating that angle. So if that's true, and we do assume a flat Earth to get that, and we get a correct measurement for the distance, I mean, what does that mean?
Well, this is another thing that I'm trying to explain it, and I don't know if I'm doing a good job explaining it. But like any authoritative text that you take on celestial navigation and you scrutinize it, they're all just like the triangle that you draw is based off of a tangent line. So it's not like it's based, and then they account for like you account and you subtract things, there's more than just drawing the triangle. It's not just a triangle.
Right, but
it's not just lines going out.
But if what I'm saying is true, right, and you can do it simpler without having to do all this, like, adding and all that other crap by just assuming a flat baseline, maybe correcting for the dip angle for observation height, which if you look into the, here's another source you can look into. It is the Introduction to Nautical Science. That book was pretty good. It explains that when you're doing the dip angle correction, which is the only correction that has anything to do with the sphericity of the Earth, supposedly, you look into it and it actually says in that introduction that it's merely a function of eye height. It's because you don't have you get a different value. Obviously, if you are elevated above the surface of the Earth, it's not a flat line on the ground. It's got to cut a little bit off because it's got to rise up to you. So what you're doing is you're correcting for that amount. You're basically flattening it out completely. That way it appears that you're on the ground on the horizon, and then you're shooting out. Again, you can use a star that's way past the horizon. So you don't have to use the sun or the moon. You can use a star. Let's say, Adam, you use the North Star, right? You could use the North Star and do this and assume a flat Earth and get a correct distance.
You cannot, not on a flat Earth.
Have you attempted it?
I mean, no. I don't have a sextant yet.
How do you know that you can't do it?
But here's the thing. You haven't attempted it either, so you can't say that either.
It's literally how the math works out. You're saying that the math doesn't work.
Well, this is what I'm telling you, that there is an easier way to do it. If you go and grab your scaled globe, you can get one at Kirkland's, scaled globe, and you take a degree and you look up the coordinates for the stars in the almanac. You don't have to do any type of mathematics. You do your dip correction, you do your index correction, you do those corrections, because that's observer height. And all of the heights are based off of a zero elevation. So What I'm telling you is you don't have to apply any formulas. You can take your compass, set it to whatever degree your sextant shot.
But your issue,
and you can make your circles, and you can get a fixed position off of a sphere. You don't need to do a site reduction. You don't need to plug in any type of trigonometry.
So I think your issue is that you're always assuming that the degree changes in the stars have to be because the Earth is a ball and not because there's a celestial shelf. When you literally look into the detailed manuals of celestial navigation, it says to assume a celestial shelf. So we have to assume that the stars are not moving in relation to each other. That's the actual meaning of it. They don't have to believe that it's a flat Earth. They can still believe that it's curved and it be a celestial shelf over the Earth, right? But they believe that the angles to the star are changing because the Earth is curving away. We can literally demonstrate that this is a product of perception because things literally change degrees and drop to your perspective when you move, and that would happen on a flat surface or a curved surface. What you would have to do is you would have to show that there's a difference between the way that it would move on a flat surface versus a curved surface, and then actually demonstrate that, which no glober has even attempted to do because they don't want to, because you'll see that it's exactly the same. And the reason why we know it's the same is because this is how we were doing it before everybody accepted that it was a globe. It wasn't just globe heads that were navigating the seas, okay? We had navigators 3,000 years ago, supposedly, people who were sailing in ships, making maps, using the stars, and they did not believe in a curved Earth. So your claim that it cannot be done on a without it being curved is completely and utterly fallacious. And you're also sitting here saying that the math does not work. That's a positive claim. You're saying the math doesn't work when you haven't even attempted to do that or even demonstrated any math that would show that it wouldn't work, right? If you had an example, you didn't even have to do it yourself, but if you had an example of somebody, you know, trying to do this and it not working, you could say, here it is. But you don't have something like that because everybody who is celestial navigating out in the real world, yes, they assume their relative position over on a big ball, but the math that they are using is for a flat triangle. It has to be. Otherwise,
No,
it
it's
doesn't work.
not. It's not even. Listen, I don't know how else to say this. It's not based on a flat triangle.
How else do you solve a triangle? Or how would you solve a triangle with a curved line then?
Okay, now this is assuming that this is going back to our previous conversation. This is, if we're solving with a triangle, then that means that we know the distance of how far the sun is. And this raises all types of problems for the flat Earth man.
You're obfuscating away from the actual point. You're trying to say,
Yeah.
well, this
I'm
means
not.
that you can't.
I already told you that it's not done with a flat triangle. And
simply
any
demonstrate
flat
it.
map that you do it on has site reductions, and any navigational map that you do it on is based nowadays.
What is a site reduction?
Here now, in reality, any site reduction and any flat navigating map that you're getting a fixed position on based on celestial navigation is done with the Haversine formula.
I don't know why you
What's
keep
that?
saying that
It's a
it's done with the
spherical
Haversine
formula.
formula when the first Google search debunks you and says that that's not how that it's done, that they literally use radar. They get actual measurements. So I'm not sure why,
Okay.
you could argue this way better. You could actually say that, well, we actually do know the distance of things because we have these radar measurements, but instead, you want to say
Without
that
radar.
we're
talking
using a
about
formula to
celestial
make maps.
navigation without radar.
That's how they make the nautical maps. So when they're making the nautical maps, they're actually using radar and and low elevation planes, taking pictures of the literal topography, and then they're mapping that out. And then from that, you can actually
and what about the
use your
open
relative.
seas?
And then from that,
What
you can
about the
actually
open
use
seas?
the stars are what's used in the completely open seas, of course. That's why celestial nav. That's
Again,
the
the
whole point.
Haversine formula. This is called site reduction. This is what I'm telling you.
Doing that, though-
This is what I'm telling you, Skylar.
Adam,
So you have never
they've
heard of
been
the celestial shelf? Then?
navigating before any of this globe nonsense or haberdashery formula or any of this other fucking bullshit. That's
David,
the
I've
point.
already addressed that though.
Because the sphere
The
is the
people of
celestial
the
shelf.
old,
It's not
they
the
had
Earth, bro.
compasses. They
Yes,
had compasses.
which
They had
again will not work on a ball.
The
A
sphere-
compass will not work on a ball, my friend.
The sphere is the
Listen,
celestial shelf,
Why
not the
won't
Earth.
it work on a ball?
Well, think because it has to be fucking flat to the ground, man. Level. It has to be level in order to be accurate. Try
That's not what
tilting your-
level means on a globe, and that's not what any
There
glober
is no
will tell
level
you.
on a globe. Don't you get that? That's the mind fuck. How can there be level on the globe? Look,
Level is just
all you
just
have
the
to do-
center
all
point
you
of
have to do is
mass.
Look at a city skyline. Look at a city skyline. Go into and take and draw a line up through the center of every one of those fucking buildings. Extend that line. Extend it for hundreds and hundreds of miles, and you will not see it radiate out as it should like a fucking sea urchin. It doesn't happen.
I mean,
there is no
we could use
curve, man.
we addressed this on the last podcast. When they build bridges, they account for curvature.
No, they do not.
range-
They
No, they
put
yes,
an
they
arch
do.
for bridge for
Yes, they do.
strength, Adam.
Yes, they do.
Adam, any curvature you ever see in a bridge is
Listen.
done for architectural strength. Architectural strength. Okay?
David,
They
when
don't
they
account
build
for any
tunnels,
fucking
long-range
curvature.
tunnels,
You know
they
why?
account for
They're
curvature.
going
When they
over
build bridges
level.
over
Why
water,
would
they
they need
account
to
for
account for
curvature.
curvature going over level fucking water? Think about the absurdity of curvature over level water.
So
Your
you,
claim makes no.
you can use stellarium to figure out the degree that the North Star is from wherever you are.
Listen, man. I see this guy talking about Gaussian surfaces, and you know the Gaussian surfaces they support globe and they support flat Earth. How about that? A Gaussian surface can bend water.
What surface are you talking about? What surface are you talking about then on a globe? You mean the one
I'm
that's
talking about
holding
the
the
surface
air
of the
in?
globe.
And it gives an even
Wait a second.
distribution.
Is that the one holding the air in? Is that the one you're talking about?
I love
The
how we
positive
jumped.
plate, the positive
What
surface.
I'm
We
telling
jumped when
you,
we could
you're
have gotten
talking
to the
about
math.
level. You're talking about level water, okay?
Right.
And on a globe, a globe's mathematics and its science describe
No, wait.
it describes it
Don't conflate those
perfectly.
two. Mathematics is not science. Although mathematics is shown to be used in science, mathematics is not science because mathematics is altogether conclusive.
I said
Hypothetical
mathematics and
however,
the science explain it perfectly.
really does it?
Yes.
How then show me an experiment, demonstrable, repeatable experiment of water adhering to the shape of a ball and sticking to it. Show
Now,
me that.
how
And
would I
don't
do
tell
that
me 'cause
when
it's
we
too
live
big.
in a plane
Don't tell
of
me 'cause it's
gravity?
too big,
How would I
because-
do that?
Adam,
I don't know.
Adam,
You tell me.
Adam,
How would you do that?
One at a time, please.
Adam, why are you answering a question with a question? He said, "Show him an experiment where water attracts to a round ball." So
And I'm
why are you
asking him,
why
how
are-
would I
but
do
why are
that in
you-
a place where gravity
you
exists?
You
Well, wait a
you
second.
answered his question with a question. So why can't you just answer
Okay,
that?
well, I can go and get a ball and put water on it, and
Right.
and water will stick to it.
It will.
Okay, can you show us that, please? I would love to see.
Before we get
Dude,
too
there's
far,
so many.
Andrew B, welcome to the
There's so
show.
many videos with water sticking on balls, man.
Oh,
Yeah.
Andrew
Is
B,
there? Can you drop the link? I would love to see. Can you drop the link?
all right, we got to.
Sure.
I'm trying to learn. I'm trying to learn. So if you can drop a link, I would love to see.
I know that we're all very passionate, but we got to remember not to talk over each other. I will be interjecting every now and then every time we get a guest, so I do apologize for that, but it would just be rude. So, Andrew B, welcome to the show. I appreciate you coming on. We are having quite the conversation here with our friend Adam Everest. We were talking about celestial navigation and how you could actually check the math, but then we jumped over to water. So, all good, all fun stuff. Welcome to the show.
All right, yeah, thank you very much. And I've been listening, but I was grading papers for quite a while, so I couldn't actually interact very much. Hopefully my audio is not going to be echoing or getting a delay this time.
You sound good, bro. That's great.
All right,
audio.
cool.
What's up, Andrew? What's up, man? What's up?
Hey,
My
hello.
My name's
So,
Austin. My name is Austin, and I live in Sacramento, California, and it's nice to meet you, man.
Oh, I live in San Jose. Cool.
Right on.
Yeah, so I was at Santa Cruz Beach yesterday with my P900. The conditions were pretty good, and there was a buoy that we could see barely with the naked eye. And I think it was about 4 miles off the coast. And I zoomed in on it with my camera right around 2 feet, 2.5 feet roughly off the water line. I mean, like my feet were in the water as the surf was coming up. Anyways, I was able to zoom in to the buoy and see the absolute bottom of the buoy and the horizon behind it. So how is that even possible if the Earth is, according to the heliocentric model, the size that it is? I've done the math on it. I've done laser tests. I've done all sorts of stuff with my P900, and it comes up. It's irrefutable, in my opinion. And for Adam, I have a question for you.
Okay.
Why do you think there's so many flat earthers that are actually, well, quote unquote, flat earthers? Why do you think there's so many of them now?
Why do I think there's so many flat earthers?
Yes.
I think, this is my personal opinion, I think that flat earthers have issues with government more or less than science and mathematics. And there is a lot of conspiracy-based theories within the flat earth community. And I think that if someone lies to you on one aspect, it's, you believe that they lie to you on all aspects. And I think that there's a community behind flat earth. And I think that when they get involved in the community, they feel love and they feel acceptance. And honestly, I think that there's a huge misunderstanding of how the world actually works. And I think that that's in part of science not addressing a lot of questions and issues that flat Earth has. But honestly, the biggest thing is I think that there is a disconnect into understanding things that they are a little bit difficult to understand. But I think that if you truly do believe that you want to find truth, right, that you will get out and you will go and you'll do research like yourself, right? You say you go out with your P900 and you take photos and you're curious about what's going on in the world around you. Now, how that applies to the Earth, right, is based on your perception. So if you have a group of people telling you that you see too far, and then you have the evidence that they carry is globe-based evidence. Oh, well, look at this. This says that we should see this amount of curvature, right? But really, in reality, that's not the amount of curvature that you should see.
Wait, well,
So-
let me stop you there for a second, Adam. What do you mean that's not the curvature you should see? Those are immutable numbers.
No,
In
8
fact,
inches.
I go as
8 inches
hold
per
on, wait a
mile
second.
squared.
No, 7.9 inches per mile squared. I'm giving you the benefit of the doubt. Okay, 7.9 inches per mile squared, and that's good up to 1,000 miles. Okay, it's the same. You can use the same math. It's right there. Okay, and you would say that we don't use science. Well, yes, we do. We don't use pseudoscience. We don't use scientism. Okay. And so that formula, if it tells me that that amount of curvature should be within that amount of distance, and I can see a target object a distance beyond that, there's one of two things happening. I'm either seeing through a hump of water or it's no hump of water. Okay, there's one of two things going on there. What is the most likely thing? That I'm seeing through a hump of water, or that there is no hump of water to see through? The most obvious answer is that there isn't one. Not some complicated refraction fucking parallax bullshit that we're fed by all these excuses by people who so desperately want it to be a fucking ball flying around. This is where this comes in. And then you take the erroneous assumption to make us out that, oh, we don't like science. We're using science. We're using critical thinking and experimentation to rule out what it is not. And what we've determined through that critical thinking and through experimentation is that it is not indeed a globe. That's what we have
Okay,
determined.
David, can I finish answering Andrew's question?
And Adam, this stuff about acceptance and feeling like part of a family. I mean, come on, that's such an tired old excuse
bullshit.
Because it's absurd. I mean, you think of what we've been up against, people losing families and friends and being like the amount that you get against you compared to what you find for you is astronomical, you know, pun intended, I guess. But
absolutely.
I mean,
It
there's
is. You
everything
get
you put out there.
ridiculed.
It's just these are just part of the narrative that it sounds like that you all have been repeating and repeating and repeating that make no sense. Like every one of your arguments. I can't believe that here we are in 2023 still having these discussions about this minutia about, well, this little bit of science says this, when the science that studies have been done, the science is overwhelming. I mean, what people have done of experiments is overwhelming. There is so much out there you can do that. I don't know if I said it in the comment section here or on another video below, but part of me kind of wishes that we would stop talking to people like you. I know the discussion is important, but I kind of wish there was just one place we could point everybody to and say, look, you got that question? It's been answered. The only ones that haven't been answered are the ones that we cannot answer and we will never be able to answer. And if we could just say, look, the people that care about it and don't want to put up a fight, because now we're down to, you've got people that are truly ignorant but might want to learn, the people that are ignorant and refuse to learn, and the people that know the truth but go against it. And I'd say, like, just have a place of truth that we can all, like, this is where we point him to. I mean, I love this discussion, but part of me also says that I appreciate this, Skylar, for having us. But part of me is like, what a waste of time these are. We keep having these same discussions over the same topic that get nowhere. When us as flat earthers, we know the reality.
Yeah.
And we've all gotten here because we were willing to change our mind. It's not because we're resistant to change our mind. I mean, I'm sorry.
I actually got to intervene on that one a little bit
years,
there.
And I just get so
You're saying
frustrated that we're just like talking to these people that are pulling just total nonsense. Now, I do respect, I don't know about Adam, but some of these people I respect a little bit because they're bringing some good ideas that make me think, not that it's going to get me to change my mind, but the majority of them don't offer anything new, right? They're just saying, like I was joking about earlier, but they pretty much do just say refraction, math, and like think that that's going to change anything. So excuse me for venting a little bit. I'm getting worked up. I'm sorry.
No, it's all right, Unknown. You just hit my buzzword. Get out of my head, man.
Yeah.
You didn't know that on my show that anytime any of the buzzwords are used, refraction, parallax, or gravity, the three excusatory words, I must hit the bomb.
I left gravity out. I'm sorry, but you'd have to add math in there.
Oh, I'll add math.
And I need to get to your channel and start watching you.
Yeah, that's the game, man. If you say any of these buzzwords, Sovereign has to hit his bong. So that's like part of the game. Yeah, you gotta if you understood his channel, you would understand what I'm saying.
I'm actually
your channel.
Andrew
you had something you wanted to add?
Yeah, Andrew had something he wanted to add. So,
well, yeah, I've got something for Adam, and then also just a comment for Unknown. I'm sorry, I don't know your name.
Yeah, Greg.
Greg. Okay, sorry.
Yeah, Live Music is my channel on YouTube.
All right, cool. I would have to say I disagree that these arguments and these debates are, well, you were saying that it's kind of a waste of time. But when I was going through all the research of Flat Earth, I was watching every single Flat Earth debate you could possibly find. And it took me about 5.5 months of just watching that kind of stuff and just seeing how ridiculous the arguments were and how the math didn't work out. And I just started seeing the dishonesty with all these people that were part of the globe culture. And I was still part of that culture at the time, but I was just looking at it, seeing it was just completely fallacious in so many different ways. So I think it does help out. So
I agree.
Come on and argue a point.
Interrupting, but let me just backtrack a little bit. That was just a heated thing. I do see how much people can benefit from it. So, that was just more.
Okay.
But sorry for interrupting you. I don't honestly think that they're completely useless.
Yeah, right. So I have a question for Adam, and I know that I asked you a question that is probably would make you long-winded for several minutes at a time, but I'm not looking for that kind of an answer. I was just kind of looking for a truncated, like, kind of an answer. Okay, Adam, do you believe that people went to the moon? This is like the litmus test for me.
Yes, I do.
That's it. And I'm done with that one.
Now I will jump at that level. When we're talking with people like that, then it's a waste of our time. 2023, and if they buy into that, I say don't talk to them. It's pointless.
So is America the only? Is America the only country that staked a claim on the moon?
Is pointless.
Research some stuff. So if they come so ignorant that they're not researching anything, and you can't.
Andrew, let me ask you a question. Do you believe in the ISS?
Nobody wants to hear your question, Adam. Nobody wants to hear your question.
All right, hey, we're not doing that.
Austin.
We're not going to cultivate that kind of environment.
Do you believe in the ISS?
Yeah.
No.
Yeah. Okay. I'm trying not to be disrespectful,
Ouch.
but wow.
Ouch.
I'm trying not to be disrespectful. I'm trying not
I learned
to.
15 years ago that the moon landing was hoax. It was progression. It was pretty interesting because I was working in charge of video. I'm in Houston.
I'm still
working
waiting
with
for
all these
answer,
astronauts actually on these jobs where I was in charge once a year of running video for them. And it was the first year that I did it for them. I had known for years that the moon landing, it was a hoax. And it was kind of interesting being around all these frauds. And I'm talking like my last year there, I called out the director, Ellen Ochoa, to her face, the director of Johnson Space Center, to her face for it, because that was the year I knew about flat Earth. But the first year I knew about the moon landing being a hoax. The second year I worked it, I had caught on to the shuttle. And in fact, I don't hear a lot of people saying that in their storyline, but it had gone from moon landing, and then I had realized the whole shuttle thing was a joke. I'm like, what what's going on? And then the next year I had known about the flat Earth. I don't know where I was going with that, but it was interesting being around
Hey,
all
unknown.
these astronauts, and they had multiple ones. And like one of the years when they had a leak in, because of course they were in a pool, right? They had a leak in their suit, and they were trying to explain it away as being some water line coming into them. And hearing multiple people from NASA get up there and tell their stories and contradicting each other. And in another room, because this was at a hospital, and it's this event called Pumps and Pipes, and it was related to the hospital system. So they have this astronaut suit in another room where they're running these tests on it to figure out how this water could have gotten into it. Anyway, again, that was a little sidetrack, but it was just
Look over
pretty
into
interesting hearing these,
look over into those messages. Unknown, look over in the messages. I put a link to my channel in there.
Oh, sweet. I appreciate it. Thanks.
I was trying to figure out
Andrew,
how to
can
do
you
that.
hear me?
I'm proud of myself. I did pretty good, man. I'm
Let me
figuring
Yeah, I
see
can
here.
hear you.
Do you believe in
Good
the
job,
ISS?
Sovereign. Good job, Sovereign. Good job, man.
No, why would any of us believe in the ISS, man?
Oh my god.
Well, I'm
Are you
asking.
kidding? In
In
fact,
what context?
okay, I will tell you,
Do you
the
believe
last
that the
year that I worked
ISS
that job-
is above us, orbiting above us?
when
With
the
people
last
inside of
time
it?
that I worked
At
that job,
200
Hey,
75 miles away?
let Andrew answer it.
Is that what you're talking about? There's people inside of it. It's moving 17,500
International
miles an
Space-
hour.
Yes.
Wait, how many?
Absolutely. That's fucking stupid.
How fast is
Okay.
the movie?
All right.
How-
So you realize that you can get on the NASA website, and it will give you the exact time and dates that the ISS will be passing over your position wherever you are, and you can go out and you can observe the ISS passing over your position, doing 17,500
Yeah.
miles, 17,500 miles an hour quietly, not breaking the sound barrier, and you can
Can
witness.
everyone? Hold on. Let's do a show of hands. How many people in here? How many people in here agree with that? Show of hands. Show of hands. Show of hands. Show of hands. 0 people.
well, Adam, that last time that I worked that job, and I doubt it was from this, but when I called out Ellen Ochoa, the current director of Johnson Space Center, to her face talking about flat Earth, it was literally within minutes of the whole crowd going outside to watch the space station go overhead, right? I know there's something up there. I know there's a light. We don't deny that. No matter how powerful our telescopes are, whatever, it doesn't look like that. We know if that was something there with people in it, why would they be obviously faking every single video that's allegedly from there? Nothing adds up. Yes, we can see that there is something that travels over. We don't have the answers to that. We're not like you Globers that pretend to
Exactly.
have answers for everything and make up math and other stuff to try to make excuses for it. We say we don't know. We admit things like we see something up there. It resembles something that looks like some blurry lights or whatever.
He said the M word.
It doesn't make it what they tell you it is. And why your mind is stuck in this, well, there's something there and I can see it on a computer and I can go outside and see a light. So therefore it must be what they tell us, even though every single other piece of evidence shatters that by showing they're faking everything.
Here's the easiest way to disprove that
You
the
can
ISS
zoom
is
in
the
on it
distance
with
away
a
that it is.
telescope.
I just brought that up and you won't see what they show us.
Okay. Okay.
They say that the,
Okay, that's the reality, dude.
what the wingspan is supposed to be the size of a football field, right?
Right.
You couldn't
So,
physically see it.
100
Exactly.
yards, right? So 300 feet. That's what they say it's the alleged size of it is. Okay. So now I want someone to go and get on any mountaintop that they want to, get any camera or telescope, and zoom into a football field 275 feet away. I'm sorry, 275 miles away,
Yeah.
and see if you can actually make that actually happen. You
Hey,
can't.
You can do it
Impossible.
on. You can do
Okay.
it on. You can do it on Google Earth, man. No shit, man. I mean, I've done it. Look, like they say, how far away
You
they
need
say
to
the
hit,
moon
man.
is and shit.
Refraction.
Yeah, right. Like,
So
okay,
if I take a cell phone,
I measured.
and I take a
Listen,
cell
I
phone-
measured one of the. They told what they tell us. One of the sizes of one of the craters. One of the major craters you can see is right. And I'm looking. I'm seeing all this detail. So I went on Google Earth and I made a line on Google Earth that was the same size as the diameter. Okay, and then I zoomed out and tried to get even above the United States to see that goddamn line anymore. And no, gone. And you're going to say I can see that crater with that detail a 250,000 miles away? Kiss my ass. That's the biggest load of crap.
Oh yeah, I've done the math on that too. It's complete bullshit.
There's no way.
It's really easy to prove too.
I think what we're seeing there again, like the sun, I think we're seeing an apparent moon. You know, that thing actually, it behaves almost like a
Sometimes.
You're muted, bro. Yeah, I mean, it behaves a lot of like I just uploaded a bunch of footage I took of the moon at different.
What do you mean
phases.
by an apparent moon?
What I mean is it behaves like a projection. It almost behaves like a projection, like a translucent light of some sort.
So it's emulating its own light. So you're saying
it is emitting its own light. Yeah, absolutely.
Oh man. Okay.
100%.
So if it's emitting its own light,
yeah.
Why do we see shadows in the craters?
Go shine a light on a rock. Go shine a light on a rock and see if it
No,
looks like.
no. We're not shining a light on a rock. We're shining the light out of
Actually,
the rock. The rock is emitting the light.
May I?
You can take and put some bits of sand on a light bulb, and they'll create little shadows and shit on the light bulb itself, bro.
No, I just have a real world example of a lit rock. I mean, I'm not going to make one claim or the other because I don't know, but I will say that a salt rock can easily prove that it's possible. Because if you look at a salt rock with the light coming through it, you can see that there are shadows and craters coming from that. And that's a really close example of what we'd be talking about if the moon was its own light source. So, yeah,
I have a selenite tower. I have a selenite.
So this is what baffles me. What is brighter, the moon or the sun?
The sun.
What? Okay, the sun is brighter. Okay. Mm-hmm. You can see the sun. Now the moon and the sun. On the flat Earth model, right? I have Dave's app. Okay, it'll show it in different positions, completely opposite positions, right? The moon is bright during the night. Sun is bright during the day. When the sun moves over to the other side, and the moon is on the other side, right? I can see the moon in the daytime. How can I see the moon in the daytime when the sun is there? But I can't see the sun in the exact location that the moon is, right? At the opposite time of day, I can't see the sun. Does that make any sense?
You're not understanding how the movements of these objects actually take place. What you have to understand first is that you have the 28-day moon cycle, and every 28 days, the sun actually laps the moon in its rotation over the face of the earth. So every 28 days, the sun laps the moon. It's not got any.
Is the sun higher or lower?
I don't know. They appear to be about at the same altitude.
So how would they lap without colliding?
Well, how do two runners on a fucking track lap without running into each other? How do two race cars lap each other?
So it moves out of the
perfectly
into each other.
So it moves out of the direction of the sun.
Adam, see, with that question, it appears to me like maybe you have not even researched where we're coming from.
No, he hasn't.
That's like 101 kind of stuff. Seriously.
Do you understand the flat Earth model, Adam? Do you understand the flat Earth model at all?
It's hard for me to understand the flat Earth model when I see so many fallacies in it.
Well, how about this?
Well, have you researched it?
And you still haven't answered the question that I'm posing. No one has answered the question I'm posing. If the moon is on the other side of the world, if the moon is on the other side of the world, why can I see it in the middle of the day?
Hold on.
When it's in the dark places on the flat Earth. But when the sun is in the same places and it's dark on my side, I can't see the sun. It doesn't make sense, David.
The sun is too far away from you to see.
It's the same distance from the moon.
Okay, stop for a minute. What you're trying to mix your heliocentric ideas into the flat Earth cosmology. Okay, that's what you're trying to do.
I asked all these questions before I started talking about this.
Adam, I'm going to answer your question, but first you have to abandon all of your heliocentric nonsense in order to understand what I'm telling you. I want you to imagine a phonograph. Okay, I want you to imagine a phonograph.
Okay.
And just for this sake. And I want you to imagine that there's a stylus, actually 2 styluses, that are floating above that record. And they go all the way from the outside groove, and they spiral in as it rotates around. Only in this case, it's the stylus that goes around. The record stays still. And these 2 stylists are playing 2 different songs. They're coming around this fucking record. The one's lapping the other one after so many revolutions every time, right? Until it reaches the inside track, gets to the end of the inside track, and starts playing the opposite direction back out toward the edge. What you have is the sun and the moon revolve around over top of the face of the flat earth. They're very near and they're very small, relatively small. They are not gigantic and far away. So you are not Superman, and you're not going to see the sun all day long because you can't see that far. Its light doesn't even travel that far. You have 2 functions.
Why
going
can I see the moon all day long?
Well, because when you're
Not
seeing
always.
the moon, listen to me. What did I tell you about the sun laps the moon every 28 days, right? So that means when you see the moon in daytime, that you're seeing, that's because the sun and the moon are in the relative same position from you. They're closer together in their laps around the moon, or around the face of the earth. So what happens is the sun gradually outruns the moon. And then it comes to a time where that's the only time you're going to see the moon is at night and during the proper cycle. And then the sun comes back around, and it all does that again. This is why eclipses are all predictable on an 18-year cycle.
What part of the country are you in, David?
I'm in the Shenandoah Valley of Virginia.
I just want to let everybody know that we are at our 10-minute warning. I'm probably not going to extend it past this because I have to get up pretty early. But I do appreciate everybody tuning in. So we're going to go ahead and try to make our final best points from everybody. Let's not talk over each other.
Right now.
Let's not talk over
10
each other
minutes
and give everybody the floor and time of day to land their plane. Whoever wants to go first.
Yeah, I'll go ahead and start. The first thing that I was in conflict with was understanding that the moon landings and NASA is complete bullshit. And that was like the main step for me. As soon as I started seeing all the fakery when it came to the ISS and the moon landings and just how really, really bad it was, then I started looking into other things. So Adam, when I asked you why you think there's so many flat earthers, you saying that because we want to be like part of a community, we want to feel important or something like that. That's incorrect entirely, because I came to this conclusion on my own, and it was fucking like taking a knife out of my stomach. It was painful for me. I didn't want to do this. It was just the fact that I found out that I was being lied to my entire fucking life. So if you want to continue to go along with that whole model, then you're welcome to. I mean, people can believe in whatever they want, but I'm just telling you that there's a reality that is being hidden from you. So do with it what you want.
Right on, Andrew. Thank you for that, man.
Yeah, I'm just going to end it out by saying, you know, the world's spinning, but the earth remains stationary. I'm only responsible for what I say, not for what you don't understand.
And I just want to say thanks to Skylar and thanks to you other guys for having me on. I don't often do these. I've only done probably a few little live ones. And excuse me for getting a little heated there for a moment where I speak quickly and loudly. But anyway, I appreciate the opportunity and look forward to some future times.
Absolutely. I appreciate you coming on, Craig. Adam, David, you're up.
I think
Austin.
Yeah. I don't have much to say. Yeah, I don't. I mean, it's hard convincing. Nobody's ever been convinced that the earth is flat. Nobody's ever been convinced. It's a self-understanding that you have to come to. It's not. It's not. We can't. I mean, people can only tell you so much, but it's about understanding within yourself what the truth is. So I mean, that's what I've figured out over the past 6 years since I found out that space is fake. So yeah, that's all I got to say, man. That's it. Thank you for letting me on. That's it. Man.
Yeah, absolutely, Austin. I appreciate you coming on. It's the first time I've seen you on a live or anything, so it's definitely nice to see some new faces. Everybody is welcome regardless of what side of the fence you are on. I know that things can get heated from time to time, and I do feel out the level of moderation that is needed because I do feel like everybody's adult and can handle themselves for the most part. So, but if it ever gets too bad, obviously we start dropping the hammer a little bit. But I do like that everybody, for the most part, was able to get out their points. And let me go ahead and pass it on over to Adam or David, whichever wants to pick it up.
Hey, thank you, man. Thank you. Thank you. Have a good night, man.
So I guess I'll close with first of all, I love having these debates. I love having these conversations. As much like I don't really get upset when it comes to this stuff, man. It can get a little bit frustrating, but at the end of the day, I just find it frustrating that someone can come in here with information that doesn't align with yours and it can just get disregarded and thrown out. And there's a disconnect a little bit on what is actually happening in reality, I feel. Because at the end of the day, we can observe things and things aren't always what they seem, right? But there are testable things that you can do. And I think that tonight, we talked a little bit about celestial navigation. We could have got into it a little bit more. An extremely accurate way to find your position. I encourage all of you guys to really dig into it and look and really see what's going on. And just understanding that no matter what's said, it's a spherical model that we use when we do fixed positions. And then just basing it on, I did agree with a lot of things that the guy, I forgot his name, he was on earlier. I'd like to get in another conversation with him. But the things that we're taught about in science, I won't say that they are always true. Okay. There are things that you can, and this is what the beauty of learning science is. No one is telling you what to believe in science. It is supposed to be a method of which they can tell you how to conduct an experiment and report what you see. And this is what I try and do. I try to conduct experiments at my home or out of my home and just report what I see. And I think that, again, the disconnect comes from when I report what I see and the knowledge that I've contained within my body and my mind. If it doesn't align with a lot of flat earthers, then it just gets thrown out. Oh, well, you don't know what you're talking about. I had a guy tell me
celestial navigation, because you're saying that
Okay.
right now. And what if I could prove to you that's absolutely, completely fallacious?
About what?
About celestial navigation being used on a spherical model.
By the way,
What if
we'll
you found out that
cut
was
off, what, in a
completely
minute?
wrong?
I mean, I prove it. Yeah.
Okay. Merchant Marines, the Navy, every Navy. Before there was like the Loran system, for example, what did they do? They based it off of celestial navigation, which was based off of what? The North Star.
Elaborate. Right? Okay.
Okay. How the hell would they do that in the southern part of a sphere when they couldn't see it?
So it was only based off of the North Star. That's what you're saying.
That's what they based it off of, yes.
So let me ask this question. So you're saying that the sightings from other stars were considered in celestial navigation?
You'd have to have a certain type of
The-
instrument to do it, right?
well, yeah, we've had instruments for a long time, man.
I'm not trying to be constant.
I mean, before the sextant,
Sorry, I'm just-
before the sextant, we had astrolabe. We had other instruments before that, right?
Okay, so
So
all of the maps that we
so
currently
you can
are
roughly
flat maps.
navigate any sea, right? And they're all based on spherical geometry.
You know that's completely illogical, right?
You cannot get a fixed position, a fixed lat longitude position on a flat map without using spherical geometry. You cannot do it.
What?
Yes, what?
Okay.
You can't do it, Andrew. When you're in the open seas, in order to make a site reduction, you need a certain formula that's going to give you a fixed location. You can't do it. But you don't need spherical geometry when you have a sphere, and you can take a compass and you can draw all of your angles onto the sphere.
You know what's funny?
Compass.
I don't need any math at all to tell me that the sun's not 93 million miles away, that we're not on a curved Earth, or that we don't move. I don't need any math.
Well, Craig,
I don't need to have ever
if you
gone to
did use math
or read a book or anything. Nothing.
If you did use
what?
math,
That's the beauty.
and the sun were, let's say, 3,000 miles away, you could
What?
use a squared plus b squared equals c squared, and you could find out that the sun is
By the
going
way,
to be
we are gonna
thousands
be
more
off.
miles away the further distance you go away from it.
Oh no, looks like we got cut off. Well, let me bring it. Nah, you know what? Yeah, I'll bring it one more time. One more time. Because that was just getting pretty interesting. But we will cut it here in just a moment. We never did the Q&A. Holy shit. Sorry about that. Maybe we'll do it here in just a moment. I definitely don't want to go longer than 2:30. That's insane. Alrighty. Copy link. We are back. Round 4. Everybody come on back one more time. Just can't help it. We just love the True Earth debate. Gotta keep it going. Come on now. Chat wants to be a little slow. That's okay. Boom. Send. All right, guys. I look forward to seeing everybody back in here to go ahead and wrap up the exciting conclusion of the True Earth debate. Welcome back.
Hey.
Yeah, we couldn't end it like that. No way. So. Not on a cliffhanger like that. I hate cliffhangers, so we're gonna get a nice strong finish.
Well, that's the way to bring people back in for the next one, right?
Oh yeah, well,
Marketing.
Shoot. There's a way to do it right. If you don't do it right, you just piss everybody off. So
Yeah.
We'll see if Adam jumps back in. I was actually trying to do some math, and that's why I was looking at my phone a whole lot, so I do apologize. That was good fun. How often do you stream? Nice. Yeah, Ruhif can be a repeat Glober. That's awesome that we can have somebody to actually bounce around some of the higher-end Globe Earth, V Flat Earth topics. That was fun. I think Adam...
Yeah, it's good when you have somebody that's actually... even though we may not agree with it, presenting something when we see like more than half the time these days, it's just somebody repeating a narrative, right? So that is good to see that row off or whatever, bringing something different to the table of some substance.
That's huge. That's what it's all about.
Yeah.
That's why as soon as he
Yeah,
started
we
doing
can
it,
learn from that.
as soon as he
Sure.
started doing it, I was like, oh yes, that's exactly why we do this. So I completely agree with you, Andrew. That's why I have these debates, that there is a good place for them, and that there's still new people, a lot of people who don't know this information, who don't know how to debate this information or how to logic it, is a better way to put it. So I think that this is a invaluable service that we provide over here. So I do appreciate you guys being part of it. I did get a text from Adam. He said that this was fun. I'm not sure if he's going to be hopping back on or not, but I'll give him just a few minutes. But I will go ahead and let you guys say your final piece since you're here. I definitely appreciate you sticking through to the end. That includes everybody in the chat. Let me do just a very quick, very needed shout out for the chat because it's been a little bit. We have Creature, Daryl Patton, Jeremy Bird, Austin Murphy. Heck yeah, still here. Question the answers. Much love, Troubling Tribune, staying up late and keeping the show on. Heck yeah, you know how it is. The show must go on. Jay Craft, how many sides does a sphere have? Awesome. Okay. Big Pine Sailing, always a pleasure. I love that comment. If you repeat it, it is true. Adam definitely seemed to believe that. Jamarcus Trunk. What else do we have here? Creature, Troubling Tribune. Thank you, brother, for continuing to give a platform for these discussions. They are absolutely necessary and do wake people up. I hope to hop on one day and help spread the truth. Absolutely. I dropped the thing in the chat like a fucking 100 times. Excuse my language. So the more the merrier. Omega Genesis, Effed Up World. Just making sure I get everybody in here. No Despair Bear. My goodness, lots of people jumped in when I wasn't paying attention. Byron, Rob Cleveland. If there's anybody that I'm missing, I am sorry. There's so much, and there's a lot of repeats. Sovereign Soul, Unchained Mind. Very, very cool. Go and make sure that you guys give him a sub. He's got some good stuff. Alrighty. And then finally, let's go back over to the Rokfin. We have Andrew, huge tip. $10. Hey, we really appreciate that. You know what that's going towards, my friend. It all is for the better show. That way, the more, we increase the production value, the more audience that we'll be able to reach. So we definitely appreciate that. Okay. We have Nuba, Mischief Brew. Of course, Andrew B. will shout you out again, my friend. And I think that will do it for the Rokfin. Alrighty. I appreciate you guys sticking through that. I'll go ahead and turn over the floor. Unknown or Andrew, whoever, the floor is yours.
Well, I'll just start by saying again, I hope and think that I prefaced it this way when I mentioned earlier that hinted, or more than hinted, that sometimes I think these are worthless. I said that part of me thinks that. I do, again, I'd already stated this, I do realize the power in them. So I do, appreciate the platform. Obviously, I wouldn't be here if I didn't. And I really don't know what to say. There's so many things that race through my mind when it comes to, I can't point to one thing, that there was somebody in the chat that happened to not be on our side, what I could possibly say to change their mind. I'm just, again, thankful for the opportunity. Look forward to the next time and hope to bring some more substance than I did tonight.
Absolutely. Hey, well, I think you did fantastic, man. So don't beat yourself up.
Thanks.
But I will always appreciate some more content for next time. So I think that this went really, really well. There's very few audio issues. People were able to share their screen and present. So I think that this is probably going to be something that I do fairly regularly. That way we can go ahead and grow the audience for it. I love the open panel. I really want to try to push it to the limit to see how many people we can get in here and it still be a functionable discussion. But that's for a whole nother time, I suppose. Andrew, take it away, my friend.
Oh, I was gonna say something. I kind of lost track of what I was going to say, but the big thing I would say about flat earth is not because it's a community. And when I was into it for the first 3 years, I never even gave a thumbs up to a flat earth video or a thumbs down to anything else. I was just watching, listening, observing, never even typed in chat, didn't even call into a show for like 3 years. And then I was like, okay, well, I'll go ahead and do that. I kind of, break the ice a little bit and see how I can do online. And it turns out that I'm talking to intelligent people. But on the reverse side of it, every single time I talk to anyone that has anything to do with the globe, they always refer back to the moon landing was real. And there is I would rather cut off my fucking hand than believe that the moon landing was real. There's no chance that was fucking possible. I have 2 family members that worked for Lockheed Martin. My grandmother was the secretary to the CEO of Lockheed Martin, right over in Sunnyvale, California, not too far from where I live. And she would have to burn classified documents and stuff, part of, after there was like a meeting, but she would have to go through them and make sure that they were actually, every page was there and she got to read them. And she knew a lot of stuff. And whenever there was a rocket launch that was being for anything NASA, she would just laugh at it. And we didn't know why she was laughing at it, but she was laughing at it. And then when she died, my dad read her diary, and even in her diary said that she has information about the space program that she will have to take to her grave, and she did. So no one really knows what, but there's obviously something going on with Lockheed Martin. And my uncle, who's now a retired engineer from Lockheed Martin, is basically saying the exact same thing. It's just a bunch of nonsense. So that's my personal experience with it. So if people want to call me a fraud or whatever, call me up. I'll talk to you. That's it.
Absolutely. Well, I definitely appreciate everybody coming on. Andrew, you're always welcome on. Ruth Hill, who was on earlier, he's always welcome on. Unknown, what was your name again? I'm sorry, I'm terrible with names, and I just keep reading unknown, so it's getting implanted on me. You're muted.
Yeah, Greg, and my YouTube username is just live music. You might find a few interesting things there, not flat earth related, but and it's been a while since I posted, but
YouTube would suck if it was all flat earth things, man. So I'm glad that it's not.
Yeah. But there's one thing I would like to add related to the NASA. So being in Houston, of course, a lot of people around here work there. Like I told you, I had the jobs working out there with a lot of astronauts.
You're
I have
actually,
a brother-in-law.
I was going to say, you're actually from where I was born, so that's actually pretty crazy
really?
that you're from Houston.
Yeah. H-Town. So I have a brother-in-law, for example. He has a telescope and buys into all this stuff. And he was working for a few years for a company that created some big stuff for NASA. And people, on the Globe Earth side are always asking us, why would all these people lie? And as we often tell them, they're not all lying, right? We're all indoctrinated, and it's so compartmentalized through NASA. Everybody wears a different hat, and they're so far removed that they don't. My brother-in-law, who was helping design some of the stuff for NASA, he legitimately believes in it. And that's what we see. So I wanted to touch on that not everybody has to be in on it. It only has to be a few people. And if somebody hasn't heard this, when you think about a control center, when they have those computers we're sitting at, literally, as we know, all it takes is one person at a computer sending data to all of those computers for them all to buy into it. So theoretically, it could be literally one person that would control the minds and the sense of all of them. So
yeah, Gus Gruesome, it's funny you brought that up, because he actually said, before the Apollo missions even did, that the technology was so good that our simulations were so good that no one was going to be able to tell the difference between that and the real thing. They were bragging about how realistic it was, which I think is absolutely hilarious. So yeah, it's even easier to fool your employees, I feel like, than it is to fool somebody who's not in the biz. Because once your money gets attached to it, you kind of have a certain level of suspended belief, I feel. But that's, a personal bias. Not that someone can't turn that off, I suppose.
Yeah, don't forget what William Casey, who was the CIA director, he made the quote, we'll know our disinformation campaign is complete when everything the American public believes is false. So it's just a huge fucking lie. That's their goal.
They love it too. They love admitting it and getting away with it. Gets them off, as Alex Jones would say.
Yeah, and I've worked for 3 government agencies, federal government. Well, sort of. I was in the military, so Department of Defense. After that, I worked for as a electrical contractor for the Department of Corrections. So I got to go into prisons and jails and stuff and do work. And after that, I worked for the Department of Veterans Affairs until I figured out this is the last time I'm ever going to work for the federal government because of how fucking corrupt they are. And I mean that from the bottom up, but it's from the top down is actually more accurate. The more people have money in the government, like credit cards, like government credit cards, they abuse that shit so much and they get away with it. So at that point, I quit. I'll never work for the federal government again. So don't think that just because the government is telling you something is real, that it's actually real. Because most of the time, it's like watching the news. They get the weather report wrong half the time. So, all right, that's it. I'm done.
All righty. Craig, live music, Andrew B. I appreciate you guys helping close out the show with me. It has been a late night. I do appreciate everybody in the chat commenting it up, chopping it up, everybody who tipped. Andrew, Nuba, Mischief Brew, everybody who normally throws their support. We'd always appreciate you guys. Yeah, we are doing a show Monday. We are going to be... Man, I haven't freaking decided on the title yet, but stay tuned because we are definitely going to be doing something. Another exciting episode of the Tribune Show. I'm going to be dropping the gravy, so definitely stay tuned. We'll do that either 10 or 11 p.m. Eastern Standard Time. That way we're not getting in the way of Jaren's stream. I'm pretty sure he does it every day at 3 o'clock now. It's crazy. He's trooping. But yeah, appreciate everybody tuning in. I look forward to seeing you all again. I hope everybody has a good night. Until next time.